Imagine one person running a busy food truck. They're taking orders, grilling burgers, dropping fries, making change, and handling out food all at once. If 5 people order at the same time, the cook forgets that there are no onion on burger 3. They burn the fry and give out the wrong change. This is a single monolithic LLM problem. It's like a standard AI chatbot that's trying to handle a massive prompt. With different rules, tools, and tags, its context window gets overwhelmed and begins to drop instructions, and this eventually leads to something called hallucination. My name is George, and I'm your instructor for this course. I've built multiple multi-agent architectures and infrastructures running in production, and my goal is to transfer that knowledge to you in the course of these videos in this course. Now, look at a high-end restaurant where you have an expeditor, and they don't cook any food at all. They just read the tickets and manage the flow of information. They yell steak to the grill chef and salad to the prep cook. Now, the grill chef only knows about meat, so they don't care about the salad. By separating those concerns, the kitchen can process hundreds more complex orders flawlessly. This is a multi-agent system, and in this course, using Google ADK, we are going to build the expeditor and hire the specialized chefs, ready for anything you want to cook. Now, obviously, in this case, we're talking about software. But by dividing the label, we bypass the limitations of a single LLM and can execute enterprise-grade software tasks flawlessly. So over to my browser, you see I have the user interface for the application we're going to be building, WealthPilot. This is a custom-built Next.js application that's interacting with our multi-agent system on the backend to be able to analyze and do all of these things. So we're going to query it, and you just say, analyze APL of 50K moderate risk over 5 years. You can see our multi-agent system responding to action here. Going to go to the orchestrator. Now you can see we get a response here, so we know our agent is actually working. It says, hi, I'm WealthPilot AI Advisor. It looks like you want to analyze APL. It's responding to action, and we can see live progress information here, the different agents being called. It's now at Portfolio Advisor. It was previously at Stock Analyzer, and all of that, and final report generator, and we have a report ready. Okay, so we have our portfolio fully generated here, and we have the report as well. Now I can click on that report, and I can quickly, in a single view, view the finalized report. How awesome is this? So you can see we have an executive summary, stock analysis for the EAPL. You can see this report was just generated as well. So it's not like a previous report we put in. And recommended action as well for the stock, projected returns over 5 years, risk assessment, and you can see our nice disclaimer here telling us this is not financial advice. So this is what we're going to be building in this section. So I hope you're excited, and I'm excited to start building this with you. So looking forward to the next videos. So why exactly do monolithic food truck AI models break down? So it all comes down to computational attention. You see, the model only has a finite amount of attention heads that can go around. For example, if you try to feed an LLM with a mega prompt, like in this situation you see here, where we feed in the user prompt, the system prompt, the full chat history, multiple tool schemas, and complex output instructions all at once to the model, what eventually happens is the core attention mechanism of the model becomes completely diluted. And when this happens, this leads to something called the dreaded lost in the middle syndrome. And it's a situation where the LLM actually forgets instructions that are at the middle of its prompt. It begins to focus on the noise, and as a result of that, you get something called attention overload or hallucination, which is the eventual outcome of an LLM beginning to focus on the noise. And in the case of our food truck agent, this leads to burnt burgers. Now think about a different scenario where we have Google ADK managing this whole workflow, which is the multi-agent workflow we talked about earlier. So here, as we can see, Google ADK enforces something called a single parent rule. And this absolutely ensures the opposite of the chaos that we saw on the previous slide, because it enforces a clear chain of command, top to bottom. Now, each sub-agent here can have its own private, highly specialized prompts, but it must report to exactly one parent. Okay, In this case, we have the sequential agent router, but every sub-agent must have just one parent, and the architecture guarantees that the logic flows strict, deterministic, and easily predictable. So do not worry if you do not clearly understand what some of these terminologies mean right now that you see on screen or that you hear me talk about. And that's why you're here. And in the course of these videos, we hope to go through each of these things and you will understand them in much more detail in upcoming videos. So just try to get the broader context right now. And as we dive deeper in subsequent videos, you will have a much more detailed understanding. So how do they talk with each other without bloating the context? So how do the multiple agents communicate? The first is something called shared session state. Now you can think of this literally like the order ticket. It gets handed from agent to agent, or you can say in this case from chef to chef. So the steak chef or the grill chef, for example, never has to worry about what the customer orders because it has access to it by default and it doesn't need to see all the noise from the different agents. Okay. The second thing is something called LLM driven delegation. Here, the parent agent transfers control entirely to the sub agent. So the root agent goes dormant after delegation. So after the root agent delegates this task to a sub agent, I'm just using the root agent as an example here, but it can be any parent agent. Once it delegates instructions to the sub agent, it goes into dormant mode where it frees up resources. So it's no longer consuming all of those very important or essential GPU resources that you need, and it hands off the control completely to the sub agent. Now, the sub agent is responsible for now doing all the processing, and when it's done, it hands over its result or the outcome of its process. In this case, we're calling that clean JSON back to its parent or hands it over to a different agent. So this ensures that the flow is very smooth and each agent doesn't have to worry about the context from another agent, just the input and the output it needs to do its processing. And eventually, when the steak or the grill agent is done preparing this really nice steak for us, it hands it back to its parent. And then our parent now sees that, oh, we have a platter agent in this case, and the platter agent is responsible for presentation of the meal. So it ensures that the meal looks good to the customer. It calls the agent and the agent presents the meal in the format or the standard of the restaurant. And once the meal is fully prepared, that gets returned back to the parent or the root agent, which now packages it and gives it to the user in this case. So what really is ADK? By definition, ADK is a model and deployment agnostic open source framework for developing and deploying AI agents. But what does that really mean? What does it mean to be model agnostic or deployment agnostic? And all the fancy big terms that get thrown around all the time. What does it actually mean for ADK to be termed model agnostic? So in simple terms, when we say ADK is model agnostic, what we're saying is ADK supports not just the Gemini set of models, but you can basically use any kind of model. It's plug and play. So while ADK by default is designed to favor the Gemini family or group of models, you can actually use any model of your choice. So either Claude or Llama or ChatGPT models. You just need to plug that in and it will work out of the box. So you don't get locked into one model alone. Then next, when we say ADK is deployment agnostic, what we're saying here is that you can deploy your ADK agents almost anywhere. You don't have to deploy them on Google Cloud, but you can deploy them on Google Cloud, and you have options when it comes to Google Cloud, which includes the agent runtime engine on GCP. So this is the Vertex AI agent runtime engine. And then you also have Cloud Run as an option to deploy on GCP. But then you can decide to run your agent locally as well, which will be seen in a moment, or you can decide to run them on a custom cloud of your choice or some on-premise infrastructure that you have. The possibilities are almost limitless. You can deploy them wherever you can basically run your Docker containers. And then thirdly, when we say ADK is interoperable or interoperability of the ADK agent, we're saying that ADK is designed to integrate with existing tools, services, and workflows as needed. So this means it supports MCP, it supports the A2A protocol. You can plug it into different APIs and services. And while ADK by default has its pre-built tools, you can also extend that to use third-party tools or build your own custom tools that you can use as well within ADK. Some of the core features of ADK includes flexible orchestration, so this means you can run sequential parallel loops for predictable pipelines. Multi-agent architecture, like we talked about, this means you can build different agents in a pipeline structure that they can interoperate with one another. It has a rich tool ecosystem, so by default, ADK comes with pre-built tools, but you can extend that to use third-party tools or build your own tools yourself. It also comes with built-in evaluation, which we're going to be talking about in a bit. And you'll see how with ADK, you can self-evaluate in the process as you develop your model. So here, very quickly, we're going to look at how we can take a simple ADK agent for test run, or maybe an ADK multi-agent. Now, if you remember from our example earlier, we had commercial kitchen, right? Where we had a grill chef, a salad chef, and a platter agent. And also we have our kitchen expeditor who was responsible for taking instructions or dishing out instructions to the different types of chefs to handle them. So that's also represented here in code by our ADK agent code. So don't worry so much about what this code does, but this is what a simple ADK multi-agent application might look like, right? And we have a root agent here who's responsible for communicating back and forth with the user, taking instructions or gathering information as required, and then passing that on to the expeditor. And the expeditor is responsible for delegating tasks to the platter agent, the salad chef, the grill chef, while they perform their functions. Now let's quickly run this agent. So on ADK, one of the ways you can run your agent is using ADK run, and then just passing the name of the directory where your agent run. And in this case, we have the ADK kitchen demo. What that does is it starts my ADK kitchen demo application, and by default, it runs the agent.py, which is the root agent. So as you can see, we're connected to agent here. And if I just say hello, we should be able to start interacting with this agent or with our root agent back and forth. So as you can see, it greets me, welcome to the ADK Kitchen Brigade. I'm so glad you're here. How would you like your beef cooked? Now, we have options, medium rare, medium well, and well done. So for now, I'll just say I want it medium rare. And for salad, I want a Caesar salad. Medium rare and Caesar salad. Now, what will happen is it's gonna go ahead and delegate task as needed to make sure that it has that beef patty or that burger prepared for me. As we can see here, it has gone ahead and delegated task. And first of all, here we see the grill chef, which was called, and it did its processing and prepared the beef patty for us. And then next we had the salad chef also called, and it prepared its salad, and it ensured that it was using Caesar, which is the style that we chose, Caesar salad. And then finally you have the platter agent, which is responsible for presentation, compile the results finally and tell us, here's your delicious burger. And we can see it has all the parameters that we chose, which is medium rare and Caesar salad. Now this is one way you can run your agent using the ADK run command. Now another way that we can run this agent also is using the ADK web command. So now if I use the ADK web and I point it to the root directory, what this does is it's going to start a visual interface that I can use to interact with my ADK agent. So right now we can see this is running on port 8000. So let's just copy that URL. So over here on the browser, we're just going to go in and type in the URL we copied, and you can see that opens the ADK development kit user interface. Now the ADK user interface is an interface where we can use to interact with our agent or sub-agents. So in this case, by default, when you open the ADK user interface, it's going to search for all agents within that root repository and show them here in a select dropdown. And by default, we only have the ADK kitchen demo here because we only have that agent ready. So I'm just going to select that, and then we're going to interact with our agent. And you can see we get a response here from the root agent, which is the default agent in charge of communication. So now we get a response. It's asking us how we want our beef cooked. So we're going to do medium rare this time. Actually, let's do well done this time around, and let's do the classic salad this time around. So I'm going to say well done and classic greens. So what's going to happen now is the root agent is going to go ahead and delegate those tasks using its expeditor agent. And finally, we have our response here. You can see our burger meal is ready. It has the parameters that we chose. Well done. And we have our classic green style. Okay. Now, one benefit of the ADK web interface is it actually shows you the breakdown of what's going on under the hood. So first of all, we can see there's a transfer to agent that happens here. And you can see the grill beef agent is called and it's passed a parameter of doneness. And then we can see several other parameters get passed around for every different call that's made. So you have that evaluation in detail. Now, if you remember, one of the other benefits that we talked about that ADK gives you out of the box is evaluation. So it helps you to evaluate or troubleshoot your agents as you develop them in real time. You can actually click on any of these calls and you have event. So it tells you what the event is, what delegation or what function call is happening at that point in time. And you have request and response as well, which shows you the parameters that get passed around for requests and the response to those requests as well. You can say it's very, very detailed in the amount of information that ADK gives you, which makes it my favorite actually when it comes to debugging or building an agent locally. So that's it for this video. Just wanted to show you some of the features of the ADK web interface and how you can run your agent. This isn't really a video about the ADK user interface. We're going to talk about that in a different video. So that's it for now, and I'll see you guys in the next one. Bye for now. So before we begin this video, I wanted to mention a term I just learned about, and that term is mise en place. Now, if you don't know what a mise en place is a French term used by professional chefs, and it typically means putting in place. And it's a practice that's done typically before they start meal prep for the day. So it mostly involves sharpening their knives, organizing ingredients, and cutting boards, etc. But all of these processes or all of the steps that are done just to make sure they're ready for the meal for the day. So I say that to say in this video, we're going to perform a mise en place. Even though in our case, we're going to be setting up our development environment, getting ready for ADK development. To get started with ADK development, we have to first install the ADK software development kit. Okay, so to install the ADK SDK, the first thing we need to do is to go to the ADK website. There's a link to this in the documentation or the resources for this video. And in that link to the ADK Getting Started page, you will find or notice that there are different types of development frameworks that's supported by ADK. However, in this video, we're going to focus on setting up for Python. If your preferred development environment of choice uses Go or Java or TypeScript, then make sure you watch the next couple of videos because I'm going to be going through how to install ADK for those development environments. So for Python, which we're going to be going through in this course, just go ahead and hit the Start with Python link. And here you will see the different dependencies or prerequisites that you need to have set up. Now in the course repository, I have set up a prerequisites directory where you have the different things you need to set up to be able to follow along with this course, or to be able to set up a multi-agent development environment with ADK. Now for Python, make sure you click on the python.md. Now go through. The first thing you want to do is to make sure that you have Python 3.12 and above installed. So if you don't know how to install Python, there's a link here. Just make sure you follow that link to the official Python documentation and make sure you have Python installed for your operating system. If you're on a Mac, go through the Mac setup steps. If you're on Windows, go through that. If you're on Linux, go through that as well. So what you're trying to achieve at the end of the day is that you have Python installed and your version of Python should be 3.12 and above. You can see here I have Python 3.14.3 installed. So that dependency is met for me. Now the next thing you want to do is to make sure you have UV installed. Now you can decide to install UV before you install the specific Python version you need. But if you don't know what UV is the package dependency manager for Python. Most people are very familiar with pip. Now pip has been the most popular for a while, but UV is becoming much more popular by the day, and eventually is becoming most people's package manager of choice for Python. So make sure you have UV installed. You don't have to. If you want to use pip, you can still do that with this course. But my recommendation will be to make sure you set up UV for your environment or operating system of choice. Now, once you have UV installed, if you can do UV version, it tells you that you have UV installed. You can see in my case, I have UV 0.9.8. I'm not particular on the version of UV that you must have, but as soon as you have a version recent enough, you should be able to follow along with whichever UV commands we run, which might be very, very little in this course. The next thing you want to do after having UV installed is to make sure you have Node.js installed, because we're going to be running the ADK web interface, and that user interface requires you to have Node.js installed. So make sure you have Node.js installed. Now, if I do Node version here locally, you can say I have Node version 22. But if you have Node 18 and above, I believe you should be good. Now, once you have Node.js installed, you should already have everything you need. The infrastructure and cloud setup steps here, you don't typically need those for now. You only need those in the later parts of the course where we're going to be deploying our agents to Google Cloud. For that, you need to make sure you have the infrastructure and cloud setup steps completed. For now, I'm not going to go into those. We already have all we need for this part of the course. And once you have all of that installed, you can go ahead and use the ADK create command to create your first agent. Or you can just clone this course repository and you should have an agent directory in there, and you can just begin to run ADK commands. So use the ADK run command to start this agent here, which is our kitchen agent, which we tested earlier. Okay, so once you have all of that set up, you're ready to proceed. So I'll see you guys in the next one. So now for the likes of you who are not using Python, so maybe your development environment of choice is either TypeScript or Go or Java. Well, good news for you. ADK recently released support for TypeScript and Java and Go as well. I think initially it was only just Python and Java, but now we have Go and we have TypeScript. So if those are your preferred development language of choice, ADK also supports them. So for those who use one of those languages, just go in the prerequisites folder as well. You see I do have similar documentation here for the steps you need to take to have Go installed for that development environment. For Go, for example, you need to make sure you have Go 1.24 or above installed. And then you also need to download the Go ADK SDK. Now, to add this ADK to your project, all you have to do is run go get and the path to the toolkit in your Go project, and you'll be able to download this. If you're using Java, similarly, you have a file in here with the steps. For Java, you need a minimum of Java 17, and you need Maven as well for your build. And then for TypeScript, you need a minimum of Node.js version 24 and npm version 11.8. So once you have all of those installed, you should be able to run ADK commands. Well, in some cases, you don't have ADK CLI commands, like in the case of Java, but for Go, you should be able to have that in Python as well. So just make sure you go through the steps, and once you have all of that installed, the infrastructure and cloud setup steps are not really important for this part of the course, so feel free to skip them. And that's it for this video. I'll see you guys in the next one. Bye for now. Hello. So in the next couple of videos in this section, we're going to be talking about the core ADK primitives. And some people call this the core ADK components as well. As we know, ADK is a massive SDK, but then there are core components that make it able to perform the functions that it does. And that's what we're going to be talking about in this section. As you can see, there are several components or primitives here in this diagram, and we're going to be talking about every single one of those in this section. However, for this video, I just want to give you a brief overview of what this section is going to be about. Now, if you take away anything from this video at all, just know that there are three core components that are actually the driving force of the ADK system. And the first is what I call the runner engine. So the runner engine is the centralized orchestrating component of the entire ADK system, because they are in charge of orchestrating the entire flow. They're responsible for the back and forth interaction with the user, getting user preferences and inputs, and then routing those inputs to the appropriate agents. They also manage the calls to LLMs and tools, based on certain agent logic, session updates, yield events, etc. Now, the next fundamental component is the agent. Now, think of the agent as the brain of the AI system because quite literally, they are the brain of the AI system. And in ADK, agents are entirely stateless. Now, because they are stateless, that means they need some sort of memory as a backend storage. And that's the next item we're going to talk about, which is session storage. Now, the session component is where the agents store their data. It wouldn't make a lot of sense to batch all storage in with the in-memory of the agent. As a result, we need that backend storage. Otherwise, it's going to be catastrophic for scalability. As such, ADK uses dedicated session objects for handling memory for the agent. You manage this using either a session service like in-memory session service, or you can use the database session service for persistent production-grade memory, and we'll talk about this. Now, having covered those three core components, remember again, agents, runners, and session, now we can move on to talk about tools. So you can think of tools like hands for your agent. Tools are how you extend the functionality of your agent, help them to interact with external APIs, search for information, run code, or even call other services to get certain information that's needed. Now let's talk about callbacks. You have them here, lifecycle hooks. Lifecycle hooks and callbacks in ADK are code snippets that you can provide to run at certain points in your agentic system lifecycle. You can use them to perform certain checks, login, behavior modifications, certain functions that run at certain points, either to check certain functionality or store something in state. And in ADK, there are several ways in which you can call this, either before an LLM call, after an LLM call, several other points which we're going to talk about. The next item we have is memory. So memory is long-term storage for your sessions. So this enables the agent to be able to recall information about user sessions. If you remember earlier in the day when you chat with some large language models, as soon as you create a new chat or a new interaction, the agent no longer has memory to remember what you were talking about in a previous chat. But eventually, the systems grew to now support memory. So with memory, we can provide a long-term context from previous interactions to our agents, and our LLMs can have that context or that background information, ensuring we have a smoother interaction back and forth. Next, we have something called artifacts management or generated files. So in ADK, you can generate certain artifacts in the course of your interaction with the model, or maybe some tools that you have can generate certain artifacts. ADK allows the agent to be able to save, load, and manage these artifacts. These could be images or PDFs or other third-party artifacts that's associated with the user session. And then next we have code execution. In the course of an interaction with an agent or an LLM system, certain code is being generated, maybe to run certain functions that's desired. This could be a computation, maybe to do some calculation as well. Now, the ability of this agent to be able to generate and execute this code to perform this complex calculation is what's known as code execution. And it's run in a sandbox. Don't worry about that. We'll talk about how code execution works in subsequent videos. Next, we have models. Models are the underlying or the most popular aspect of an agentic system. This could be the underlying LLMs that actually power the functionalities of the agent, right? And here we're talking about things like Gemini, Claude, ChatGPT. These are the fundamental backend components that enable the reasoning and the language understanding capabilities of your agentic system. And then next we have events, which are very interesting aspects of primitive components, because the events are like the basic units of communication, presenting things that happen during a session, forming the conversation history, and informing agents of certain activities that are happening within the system, like user messages, agent replies, tool use. They form part of the conversation history. So you can think of events like trackers for certain things that happen within the conversation or the interaction with your agentic system. And there you have it, the core ADK primitives. Now in this section, we're also going to be building a demo project. Now this demo project is going to be a real walk-in AI multi-agent system. And in this case, this is called WealthPilot. Now what is WealthPilot? WealthPilot is an AI wealth advisor that we're going to be building using Google ADK, and its purpose is to analyze stocks, build portfolios, optimize risk, and generate a PDF report for the user based off of their investment or their risk tolerance preferences. So what we're going to be building is this multi-agent system that you see here. It's going to have a root agent which orchestrates conversations. We're going to have a stock analyst agent which fetches livestock data and analyzes those stock fundamentals. And then it's going to pass that over to our portfolio advisor, which calculates allocations and projected returns. And then that information is passed down to our report agent, which builds a PDF portfolio for the user based off of their investment preferences. Then the user has the ability to download that PDF report that's been generated for them. Quickly, let's take a look at how the system works or how request flows in the system. Firstly, you have a user who's going to come in via the interface, and we're going to see this in a moment. And they can say something like, analyze Apple stock for 50K investment over 5 years, for example. And then our WealthPilot agent or our root agent takes that, and then it calls the stock analyst agent and say, get data on APL, and it has a tool to retrieve stock prices or stock information for whichever ticker that the user provided. And then when it gets the information, it's going to analyze that and pass that on to the portfolio advisor, which is going to use a looping agent. We're going to talk about that in a moment. But a portfolio advisor is going to build a portfolio for the user based off of all the data and information it does. It's going to calculate the compound interest or compound growth over time based on the duration that the user provided. And then it's going to provide that information back to the WealthPilot agent, which will then call the report generator to generate a PDF report for the user. So very quickly, let's look at what we're going to be building in this section. The AI Wealth Advisor is going to be able to analyze stock for a specific amount for duration of time and based on our risk tolerance level. So your risk tolerance level could be medium, high, or low. Now, based off of that information, it's going to build out a portfolio report for us. And that portfolio report will be available for us to download in PDF. So what does the workflow look like? A user using the web application chat interface types in analyze Apple stock, for example, for 50K moderate risk. Now this goes into our orchestrator. Remember, the orchestrator is responsible for orchestrating the entire interactions that happen between the user and calling the necessary systems that's needed to process the request. How the orchestrator spins into action using the WealthPilot root agent. It delegates tasks, first of all, to the stock analyst, which is going to be using the yFinance API to fetch livestock data for the ticker, whichever tickers we decide to use, or multiple tickers and symbols as well, if we want to analyze multiple stocks. So it's going to use the stock analyst to fetch that information, get that data, bring it back, and then use the portfolio advisor to now calculate our compound interest for the duration of time. If we say 5 years, for example, what will our potential growth be in 5 years, depending on the amount and our risk tolerance level? Now, based off of that, it's going to build a portfolio for us, and then finally present that portfolio to us, and also present a PDF report so we can download that PDF report from the user interface, all in the same view. So that's what we're going to be building in this section. Now let's quickly take a look at this in action. Back here over to my browser, you see I have the user interface for the application we're going to be building, WealthPilot. Now all this is running locally. As you can see, we're not using ADK Web for this. This is a custom built Next.js application that's interacting with our multi-agent system on the back end to be able to analyze and do all of these things. So we're going to query it and you just say, analyze APL of 50K moderate risk over 5 years. You can see our multi-agent system responding to action here. S is going to go to the orchestrator. Now you can see we get a response here, so we know our agent is actually working. It says, hi, I'm WealthPilot AI Advisor. It looks like you want to analyze the APL. It's responding to action, and we can see live progress information here, the different agents being called. It's now at Portfolio Advisor. It was previously at Stock Analyzer, and all of that, and final report generator, and we have a report ready. Okay, so we have our portfolio fully generated here, and we have the report as well. Now I can click on that report, and I can quickly, in a single view, view the finalized report. How awesome is this? So you can see we have an executive summary, stock analysis for the EAPL. You can see this report was just generated as well. So it's not like a previous report we put in. And recommended action as well for the stock, projected returns over 5 years, risk assessment, and you can see our nice disclaimer here telling us this is not financial advice. Okay, so this is what we're going to be building in this section. How does this system work? So basically we have several multiple components in play here. We have the LLM agent. In this case, we have multiple agents. Since this is a multi-agent system, we have WealthPilot, Stock Analyst, Portfolio Advisor, and Report Generator, which helped us generate a PDF report, which we just saw. We have sequential, parallel, and loop agents, which we're going to be talking about next as we build out the agent aspects. We have function tools to fetch stock price, calculate compound growth, save portfolio report. We have agent tool, which is how you can use one agent to refer to another agent as a tool, or call one agent from another agent as a tool. We have callbacks, which are hooks or snippets that we have in certain points of the agentic system lifecycle. We have session state as well, which we use for conversation tracking and key value storage. We have memory, which is for cross-session recall. We have artifacts for file storage for generated outputs. So the PDF reports that was generated in this case, we're storing that in artifacts. In this case, we're running locally, so that storage is locally on our file system. And then we have planning, which we are using the React. So this is our orchestrator now using React pattern for multi-step reasoning and deciding what needs to be done based off of the prompt from the user. So that's the system we're going to be building in this section. I hope you're excited to get started, but that's it for this video. Now let's get on to building our agentic system. Hello and welcome back. So in this video, we're going to start building our multi-agent system. But before we get into that, let's look at what the components that we're going to be using for this multi-agent system is. So first you have LLM agents. Remember this video, we're going to be going much detailed into what agents are. So in ADK, you have two different categories of agents. You have deterministic and non-deterministic agents. So deterministic agents basically means agents that decide the workflow or the order in which execution happens. So for example, you have the sequential agent, the parallel agent, and loop agent. These are deterministic agents because there's a defined order in which they should execute or call sub-agents. And then you have the non-deterministic agent. This is when you want the LLM to self-decide when it wants to call a specific tool or sub-agent, right? Then you need to use the LLM agent. And this agent supports you using a model or model parameter in that agent declaration because the LLM will be the primary decider of when certain actions are taken. So in this video, we're going to create the set of agents that we need for our WealthPilot multi-agent system. And that is the stock analyst, the portfolio advisor, the report generator. We're just going to create the bare bones versions for now. Since this video is about agents, we're going to stick to agents. So the other two components we're going to be using involves the function tool. Function tools are just tools. In ADK, by default, when you create a tool, it wraps it in a function tool component, so you don't really have to define that it's a function tool. And then you have agent tool, which enables agents to use other agents as tools. You have callbacks, you have session and states, which we're going to be using for conversation tracking. You have memory for cross-session recall, artifacts, you have planning for React. So planning is just the process that happens before you actually start execution. And in ADK, you can actually do planning using React, and this uses a base planning component where, planning is kind of super useful. While React planning is much more useful when you're building agents that on the lane model you're using doesn't support thinking. Most of the agents now support thinking by default, so you don't really need React. But if you want to use a cheaper model that doesn't support thinking, you use React planning, so that way the agent first of all uses the LLM to plan what it's going to do and its path of action before it starts executing. So agents, like we said, there are three different types of agents. You have loop agent, parallel agent, sequential agent, and then you have the LLM agent, which is the default, which we're going to be using. So let's quickly talk about the different agent types in ADK. You have loop agent, parallel agent, sequential agent. Now, the loop agent simply means that you want to run certain workflows in a loop. So you want to continually perform a certain action until a certain condition is true. So that's the checker now in this case. So we're going to continue to run a certain set of actions until we reach a certain condition or a certain condition is true. And in ADK, you can either decide to run your loop with a maximum number of iterations where it terminates, or you can decide to put a condition that makes it terminate or leave that loop. And we can see that from the ADK documentation. If we go to workflow agents and let's go to looping agents, since that's what we're talking about right now. So you have this execution flow, and then you have a max iteration. So that's the number of time you want the agent to run before it exits that loop, right? And max at completion. Or you can decide to define a condition, or maybe a sub-agent that can check certain conditions and write an event when certain conditions are true, and that way you exit the loop as well. So that's another way you can decide to exit the loop. Now, the next type of agent we can run is the parallel agent. The parallel agent is useful when you want to run certain sets of actions at the same time. And typically you use the parallel agent when there are no interdependencies between the different agents that you're going to call in parallel. And take, for example, this could be, say you have 10 restaurants, for example, and you want to perform the same fixed set of analysis on those 10 restaurants. So this could be figuring out what the average spend is for each of these restaurants, what the average reviews are for each of these restaurants, and you want to produce some output, maybe a JSON output for each of these restaurants. And you don't necessarily want all of this to go sequentially because then you'll just be wasting a lot of compute. So you want to run this in parallel and then compute the results at the end of the computation. In such a case, you can use a parallel agent. And then you have a sequential agent which runs in a sequence, like the name suggests. So agent A runs, agent B runs, agent C. And in a sequential agent, you can take the output of agent A and feed that into agent B, take the output of agent B and feed that into agent C, since they all run in a sequence. Now, some of the key differentiator between deterministic agents, which we're looking at here, and non-deterministic agents like the LLM agent is that deterministic agents do not need an LLM or an underlying LLM layer. They basically don't require that, and they also do not care about the sub-agents or the tools that are run or implemented by their workflows. They only care about the order of execution. So keep that in mind. Looping agents, parallel agents, sequential agents only care about the order of execution and not the underlying implementation of their tools or the sub-agents that they call. So they themselves basically don't use the LLMs for anything, but the sub-agents can use those LLMs if they desire. So there you have it. Now let's get into building first multi-agent application. So right here in the right here, I have my terminal, and I'm going to be creating our agent in the multi-agent systems directory we have in here. Okay, so the first thing I want to do is to create the directory where our agent is going to live. So for that, I'm just going to do a make directory. I'm going to call it WealthPilot. Now we have our empty directory, WealthPilot created. And next thing I want to do is to change directory into that WealthPilot directory. Okay, and then now that I have that, I want to start creating the files that I need. If you have UV installed, you can as well just go ahead and do UV init to generate your empty Python project with all the dependencies that you need. But I know all the files that I need right now, so I'm just going to create them one after the other. So the first thing I want to do is make sure I create the pyproject.toml file. And in there, I'm just going to paste the configuration because I already have it just to save time. So what we're doing here is we're defining a Python project called WealthPilot and version 0.1.0, description as well. I'm calling that ADK masterclass section 2 demo and requires Python. I'm using Python 3.13 for this agent application. And I'll tell you why, because the dependency we have here for yFinance has a dependency on Python 3.13. As a result, we can use 3.14 that we used initially. Okay, so let's keep that 3.13 dependencies was defining the Google ADK dependency, and one for yFinance, which is what we're going to be using for pulling stock data. So I'm just going to save that. Now, the next thing we want to do is to pin our Python version to 3.13, which is what we want. So over here, I'm just going to go echo 3.13 into the Python version file. Okay. I'll create a Python version file, pins it to that version. And now the next thing we want to do is to configure the environment variables. And if you haven't already, please go to Google AI Studio and generate an API key because you're going to need that. So just go to aistudio.google.com. Okay, and try to generate an API key. Just go to get API keys and generate an API key. Now, we don't need a Vertex AI credentials for this use case. We're not going to be running on GCP, so no need to create a Vertex AI GCP project and set all of that up. We're going to do that when we're deploying to Google. For now, all you need is an API key from AI Studio. So go ahead and create an API key, and then we're going to create a new file in here, .env, and this is where we're going to store our Google environment key. So make sure you put your API key in here into the .env file. Now I'm just going to delete that and put my API key in there. So now that we have our .env file created, I have my credentials in there. I'm not going to show you that. The next thing I want to do is to just create the init.py file. Now, if you're creating this using UV, you wouldn't have to run this command because it will already have that in there for you. So the init.py file just designates the project as a Python project, okay? So now let's go ahead and create our actual agent file. So in ADK, you need an agent.py file, which is the main entry point for ADK to know that that's the core file containing our agents. So this is the file that ADK will look for. And in this file, by default in ADK, this file needs to have a root agent. So a root agent is what ADK will look for by default to run our agent. So I'm just going to paste in a bunch of code and then talk through so I don't have to type everything one after the other and save us a lot of time. So the first thing we want to do is our root agent, but first we need to import our dependencies. So let's make sure we have all of that in place. And in this case, we just need our dependencies for the Google agent. So let's see, from Google, the ADK, the agents, we want to import the LLM agent, which is what we're going to be using. I think I have a typo. So it's LLM agent, camel case, and then we want to import the sequential agent as well. Okay, now we have our dependencies imported. Now for our root agent, we are saying create an LLM agent. So this means we create a non-deterministic agent called WealthPilot. That's the name, the identifier of the agent. We're setting our model to Gemini 2.5 Pro, setting a description. Now the description is how other AI agents are going to see your agent. So the description is basically useful for other AI agents to decide if they want to pass control, for example, to this agent. So just make sure it's descriptive of what the agent actually does. So not just the name. So you can see we have a description of what it does, right? And then the instructions are super important because they tell the agent what its contacts are and its goal. They also tell the agent what its personality is, the constraints on its behavior, how it's used its tools and which tools are available to it, and also tells it what desired format usually to return its response in. So you can see here we're being very descriptive. Your WealthPilot is an AI pilot advisor, and we give it some instructions on what its role are, what tools are available to it. Here we're saying analysis pipeline. It contains the full sequential flow. So we're telling it to call analysis pipeline for the actual flow. So we have to implement analysis pipeline. I was saying conversational flow, greet the user warmly. Okay, so we're defining a conversational flow here. Ask about their investment goals, budget, and risk tolerance. So this information must be collected before the root agent can decide to proceed. And when they want analysis, transfer to analysis pipeline. So we're telling it to do a pipeline transfer. Now, keep in mind, we haven't created an analysis pipeline. So be conversational, warm, and professional. Always include This is an AI agent analysis, not financial advice. So this is a disclaimer that will always be included. And now we're defining our sub-agents. The sub-agent key is where we define what agents are available to this agent. And in this case, we only have one agent, which is the analysis pipeline. Now, this analysis pipeline is actually going to be a sequential agent that will trigger multiple other sub workflows. So what does that look like? I'm going to paste in a bunch of code again, and then we're going to talk through that. Now I have my sequential agent. What's in this analysis pipeline is a sequential agent, so deterministic in this case, and the name is analysis pipeline, which is how the other agent will be able to identify it. We give it a description. Analysis agent runs the full analysis, analyzes stocks, advice, and report. So this agent is in charge, basically. And then you have a sub-agent. It has stock analyst, portfolio advisor, and report generator. So we need to create those. Once again, I'm going to paste in a whole bunch of code for the other agents we need to provision. Now we have a more complete file. We have our stock analyst, we have a portfolio advisor, and we have a report generator. Now keep in mind, these are all using non-deterministic agent declarations right now, so they have access to the model. So here we're telling our analysis pipeline to call each of these models. So what it's going to do is it's going to run the full analysis. Remember, sequential. Stock analyst gets called first, so it runs the stock analyst, which in this case, we're just telling it to analyze individual stocks by fetching live market data, your stock analyst, when asked. It doesn't have any tool available to it. So all it's going to do right now is to just run using the LLM backend or underlying LLM implementation that it has. Similar for the portfolio advisor as well, and report generator. Can't really generate any actual report, but just an LLM response for now. So I think now that we have all of that established, we can go ahead and run our project. So I'm just going to save that, and I hope we have everything in place. So here, over on our terminal, I'm just going to, if you have ADK help, just to confirm ADK is well and available. And now we can do ADK web in the root directory. Okay, server started, and it looks like our application is running on port 8000. So we're just going to go to a browser and load localhosts port 8000. We can select our WealthPilot application. Awesome. So now let's just ask it a question and let's see what's available or what it can do. Okay, so I am looking for investment advice. Let's see if it works. And we got a response. Hello, I'm WealthPilot, your advisor. To give you the best possible analysis, I first need to understand a little bit about you. Investment goals, budget, risk tolerance. So these are the things we defined right here that the agent must collect, okay, conversation flow, before it calls the analysis pipeline. Okay, so we can be sure that agent actually is working. So we can go ahead and provide the information it needs, and let's see if it's able to call the analysis pipeline. Okay, so your investment goals, what are you hoping to achieve with investments? I'm just going to say long-term growth. Budget is 50K. Risk tolerance is, let's say, safe. Now remember, we haven't fine-tuned this to work like our actual multi-agent system works. So I'm just going to give this, and let's see if it's, what we're testing here is that it can trigger or transfer control to our sub-agent. So there you go, transfer to agent was called. If we click on that, over here on the left, we can see analysis pipeline was triggered. Name transfer to agent, and we can see the thought signature. The role is model, so it's a model, underlying model. And transfer to agent was triggered, and we can explore the state, the artifacts, the request auth config, and several other confirmations in here. So we are sure that the agent transfer is working. As you can see, our stock analyst here got the request. Hello, as a stock analyst here at WealthPilot, my experience lies in analyzing individual companies, blah, 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 blah. And finally, it does this analysis, returns the result as well. And we have our outputs here. Okay. And this is the output from, let's see which agent, stock analyst. And this is the output from portfolio advisor. So stock analyst did its findings and then passed that information over to portfolio advisor, which then ran and analyzed the portfolio or potential portfolio based on the information we've provided. And we can see the text here in full. We can see the agent transfer. We can look at the request, system instructions, the user's text, and we can see a lot of information here. And then finally, we should be getting our response from the report generator. So we know that the report generation is also working because we have a completed report here. Now, all of these agents are backed by LLMs in this case, so we don't really have full control of the order in which execution happens, of the structure or generation of a PDF report and all of that. So in upcoming videos, we're going to be breaking everything down one step at a time and building or enhancing the implementation or the functionalities of each of these agents to be able to achieve the full functionality we need from our multi-agent system. So that's it for now. I'll see you guys in the next video. All right, welcome to this video on ADK Tools. In this video, we're going to be going through what tools are in Agent Development Kit, and we're going to be augmenting our application that we built previously, or our multi-agent application, with tools to be able to fetch stock information, get company information, and begin to look smarter in a way. That's what we're going to be working on in this video. Tools in ADK are a way to extend the functionality of your agents by either using custom functions or using built-in ADK tools. So believe it or not, ADK has built-in tools or integrations, which they call it, that you can just plug and play. So the first place I'll recommend if you want to use or build any custom functionality for your agents using ADK is to first go to the ADK tools and integrations and check out the tools that's available there. And if there's nothing that actually catches your fancy or matches the use case for what you're implementing, then you can go on to build a custom tool. So there are a bunch of tools here for different things: search, Vertex AI, Google MCP, observability. There's a whole bunch of stuff here. Okay. So first go here, try to find if there's an existing tool for what you're trying to implement. And if there's none, then you move on to custom tool implementation. So if you're building a simple multi-agent system, like in our use case, we're going to be building a custom tool for that. So let's get into it. Now, back here in our multi-agent application, WealthPilot, to be exact, we want to augment Stock Analyst with some tools so it's able to fetch live stock information from yFinance. Now, remember, we added yFinance to our Python project here. We're going to be using that to fetch live stock information. And then, based off of that live stock information, our portfolio advisor can now use that stock information to actually provide intelligent information to our user. The first thing we want to do here is to create a tools directory. Now you can actually add your tools in here in this file, but I just think it's going to get a bit messy, so I prefer to have a separate directory for tools. So we're going to create a new directory here. Let's go into our WealthPilot directory, and we're going to make a directory called tools. Okay. And then within that directory, we're going to do a touch init again, just to make sure it's the Python function we can execute. So now we have our tools directory, okay, empty. Then the next thing we want to do is to create our stock tools. So within the tools directory, so for that, I'm just going to create a new stock tools.py file in here. I'm just going to go here, new file. We're going to call this stock tools.py. Okay. Now in here, I'm going to paste a bunch of code in here now just to save time, and then I'll explain to you what that code does. Now, here we have two Python functions. You can see this is just standard Python functions because in ADK, when we define tools, ADK automatically wraps that function in a function tool, so we don't have to wrap it in function tools. But basically what we have here is you have functions. First of all, you have the function name, okay? Now the function name is very important in ADK because it is how the agent or the LLM is able to identify your tool that needs to be called. So it's very important because it's how the LLM sees the tool. So it's very important to be descriptive. Don't use very generic names here. Just be descriptive of what the tool does. So you can see we have fetch stock price and we have get company info. And here we're importing the yFinance package from YF, which we already have in our Python project, the toml file. The next thing we're doing here is we're setting a docstring. Now, what is the docstring? Well, apparently the docstring is very important in tool declaration in ADK because the docstring is what tells the LLM what your tool does. And it also tells the LLM what arguments or parameters your tool requires to be able to perform its function. And it also tells it what return value it should return or your tool returns. So in this case, we're telling the LLM that the argument that our fetch stock price tool needs is a ticker symbol. So maybe Apple, Google, Microsoft, or whatever it is. And it's going to return a JSON string with the price, market cap, the price per earning ratio. So if you don't know what that is, it's a very significant price to earning ratio that's used to determine if a stock is either overvalued or undervalued. And then we're going to fetch the 52-week range for whichever stock that's provided. Now, all this information is provided by the yFinance library. If you need to check that out, I'm going to leave a link in the resources section. Okay, but yFinance uses Yahoo Finance to provide us with free stock data, live free stock data for any ticker symbol that we provide. Okay, so with that out of the way, we have our tool name, we have our docstring, and then our actual implementation of the tool. So here we're just declaring the ticker and then fetching the stock info and then returning a JSON dump. So you can see here we're specifying that our tool is going to be returning a string. Now this is going to be mapped into our Python dictionary. Anyways, but we're saying here we're returning a JSON dump of all this information back. And this information is going to be used by LLM to now decide or pass that information to a portfolio manager to be able to give us much more useful informations. Okay, and we're truncating the description. Now let's look at the company information. Likewise, we have the tool name, we have the parameter it expects, which is the ticker, and we have a docstring with our arguments and our return values, very important. And then our actual implementation here as well, we're getting the business information for the ticker that was provided. And something important you'll notice here is we're truncating the summary or the business information to the first 500 characters. So we don't want to overpopulate our context with the description from the company. So the first 500 characters should be sufficient for us. We just need a summary of the company. Now that's all our tool does. Now that we have our tool, we can go back to our agent.py file and wire in our tools. So back here in our agent.py file, the first thing we're going to do from the top of the file is to import our tools. So I'm just going to go from tools.stock tools, which is as defined, and we're importing fetch stock price and get company info. Okay, now we have that. The next thing we want to do is to update our stock analyst so it knows about those tools, because right now it doesn't know about the tools. So we need to update our instructions so it knows about the tools and also pass in the tools parameter so it knows the actual names of those tools to actually call those tools. Once again, I'm just going to replace the code there with a new version and we're going to talk about it. So now we have our updated stock analyst. We're still using LM agent. Now in our instruction, first of all, we're defining the role or the goal of this agent. We're also specifying what it does here. So we're telling the LLM what this agent does. And we're telling the agent about its tools. We're telling the agent, use the fetch stock price to get the current price in key metrics. Use get company info to get company background. Provide a clear analysis or concise analysis covering current price, week range, company, the brief outlook, and keep your analysis factual and data-driven. Do not make specific buy or sell recommendations. Now, finally, make sure you add this. So here we're telling the agent the tools that are available to it, which we've imported here from the top. Okay, so once you have that ready, we should be able, make sure you save the file, we should be able to run our ADK application again, and then see if it's able to detect and use those tools. So now that we have all our changes in place, let's go ahead and start ADK. I'm going to start ADK using UV this time around because I want to load the updated dependencies like yFinance that we just ordered, right, in our virtual environment. So we're going to do UV run, set the project to WealthPilot, and then run ADK web from the root directory, okay? All right, so now we have that started. Just going to refresh again, and we're going to select our WealthPilot, make sure that's selected, and we're going to say analyze AAPL for me. Now, let's see. If it's working, it should be able to call our tools to fetch the stock information, fetch company information. Okay, there you go. So fetch stock price, we can see the ticker symbol was passed, AAPL, which is saved in state, and we have get company info also running, so we're able to get information about the parent company, which is Apple in this case. So you can see there's a response from get company info. Stock analyst is able to fetch information about Apple, about the Apple stock, about the company, so we're sure that everything's working. Okay, so portfolio analyzer can now use that information to do an analysis. Okay, and now we have a much more responsive and useful agent. So we have a report here again, but this time we have useful current price information, previous close, P&E as well, forward P&E, dividend break. You can see our agent is becoming much more useful with just the single tool addition that we've made. So that's it for this video. Okay, and in the next one, we'll continue optimizing or improving our multi-agent system. I'll see you guys in the next one. Bye for now. So, hello again and welcome. In this video, we're going to talk about ADK callbacks. We're going to discuss what ADK callbacks are, why we need them, and what are some of the use cases where ADK callbacks can be very important or very useful. So ADK callbacks are functions or tools that help us control the execution process of our agentic system. Basically, they hook into certain points in the lifecycle of our agentic system, and they allow us to be able to either modify or extend the behavior of our agentic system or agents, providing increased flexibility for our agentic system. Now, a nice analogy I like to use is airport security check. Whenever you go to the airport, your luggage is going to go through several security scans. And there's a likelihood that at each of these specific checkpoints, your luggage can either be inspected, which it will be, modified, because there's a likelihood that it's going to flag something, and they're going to have to take out several stuff from your luggage. You may not leave with everything you came with. So, a modification. And as well, there may be a rejection where you're stopped from proceeding with your flight. So those checkpoints are exactly what callbacks are in ADK. They are standard functions that you can declare, and that can help you control the flow or the execution pipeline or workflow or process of your agents. So where do callbacks hook in? If we look at this diagram here, this is just simulating what a standard user request is when it comes into an agentic system or an agent in ADK. So user makes a request, you have the before agent hook point, and down at the bottom you have the after agent hook point. Now, in between those two hook points, you have everything the agent does. The agent decides what to do between the before agent and the after agent hook points. So you can decide to call a before agent callback, which tells the agent to call that function to do something before it starts its actual work. Or you can decide to have an after agent callback that tells the agent to call that function before it returns the result to the user. Now, those are not the only two hook points that exist in ADK. You have several other hook points, and the next one is the before model and after model hook points again. So just like before, you have the before model, after model, and in between is where you make your actual LLM call, or where your agent calls the LLM. You can decide to hook to the before model hook points. This means you want a certain function to run before the agent calls the LLM. And another hook point is after the model has returned its result. Now, why would you want to do this? This could be for several reasons: monitoring and troubleshooting, Guardrails implementation, authentication, state management. You can control what happens before and after the model has returned its response. And you can also use this for caching, because you can decide not to proceed with the LLM call by using the before model callback. And then we have tool execution, before tool and after tool. So here you can also control what happens before the agent calls a tool or what happens after the tool has been called. So you can decide to proceed or override the result of the tool call. Now, what happens or what controls if the agent is actually going to override the result of a call or maybe ignore it is actually the return value from your functions. By default, when you return none from your callback function, you're basically saying proceed normally. So maybe you're making some modifications to the state or whatever, but the result of that callback is not going to modify the standard execution process. But when you return an object, then you're either skipping or overriding the default behavior that call point was supposed to achieve. So if it was an LLM call, you can decide to return an object, and that object will be used to replace what the LLM was supposed to return at that point. So that's how that works. So now that we understand how callbacks work, we're going to go ahead and integrate some callbacks into our WealthPilot multi-agent system. Now, if you remember, we stopped at a point where we had tools working. Now we're going to go ahead and implement callbacks. Now we're going to proceed to implement some callbacks in our multi-agent system. We're going to be building callbacks for validate ticker, add disclaimer, and audit log. So validate ticker basically will be a way for us to validate that the ticker symbol provided to our tool or to our agent is correct before we call yFinance to fetch stock data. Add disclaimer is we're just going to return a string as a disclaimer or as an advice that this is not financial advice. And then you have the audit log, which we're just going to run just to track that certain agents have been called or have been triggered. And we're going to use the before agent hook for that. So let's get to it. All right, so now let's proceed to implement some callbacks for our agentic system. So like always, I'm just going to go ahead here and first of all create a callbacks directory, just the way we isolated our tools in a tools directory earlier. We're going to go ahead and create another directory here called callbacks for callbacks. So I'm going to run make directory. First of all, let's just go into the WealthPilot directory and we're going to run make directory callbacks. And within the callbacks directory, we want to create the init.py file again. So this will be callbacks. Okay. Init.py. So now that we have that, we can now go ahead and start creating our callbacks. Within here, we're going to create a callback called Guardrails.py. Now, like before, I'm just going to go ahead and paste in some code and then explain what the code does step by step just to save time. All right, so we have our code in here. Now, what does this code do? It's basically just a bunch of Python functions like you'd expect, but you notice some of them have callback context and some of them have tool context. Like this, for example. So these are before tool calls. Now, the first callback we have here is a before agent callback, and it's for audit login. So all we're doing here, we're just printing a string called audit, and we're saying agent invoked. So this is going to tell us that a particular agent has been invoked whenever the agent is invoked. That's all we're doing here. And just like before, when we created tools, we have a doc string here that tells us what this function or this callback is about. And by default, ADK, if you want to, provide you a callback context and also a tool context, which you can use for before tools or after tools callbacks. It provides you additional information on context about the agentic system, and you can modify certain key value pairs as needed within your callback functions. But in this case, we're not really modifying anything. We just set an agent name called callback context.agent name. And then we're printing audit agent name was invoked. Like we said earlier, you can either return a value or an object, or you can decide to return none. But if you return none, what you're basically saying is you don't want this callback to impact the execution flow of the agent. So the agent is basically just going to continue with whatever it was going to do anyways. So then you have the after model callback here, which we're going to be using for our financial disclaimer. And here we have the callback context again, and we have the LLM response here as well. Now in this case, we're not really using the LLM response, so basically we can even take it out. But optionally, we're just using it here to tell you that you can actually return an LLM response object, which will replace the expected response from the LLM model. So in this case, we have our docstring again, and this logs after every model response. It returns none to pass through, so it doesn't impact or override the LLM's response. And we're just saying disclaimer, model response from agent name. Then we have a before tool validation here. Now this one actually does something. The before tool callback here is used to validate that the ticker symbol that we're getting or we're passing is actually correct before we call the yFinance API. So this is one case where you really want to use a callback, and you can start to see the impact of using callbacks. Here again, we're saying tool base tool. So just inheriting from the base tool, passing some arguments, and then for tool context, we're passing tool context as well. And optionally, we're returning a date. In this case, we're going to return none as well, because we don't want this to modify the standard execution of the call of the tool. We want it to still call the tool, but we just want to validate that the ticker symbol is correct before we call the tool. So a docstring again here, and then we're sending tool name to tool.name. And then we're checking, first of all, we're checking that the tool name that's been called falls in the names of one of the tools that we have. So you can use this as a validation check to ensure that certain tools that you don't want called are not being called. So if this is running for every tool that's called, then in this case, we are doing some validation here to ensure that the tool that's being called falls in one of this list. And then we're returning none if the tool is not in any of this lists. But when the tool being called is in one of this lists, we're proceeding to process the ticker symbol, and then we're doing some validation as well. And then again, we're doing some more validation here for the formatting of the ticker symbol. So we have our callbacks implemented. The next thing we need to do is to integrate or plug in these callbacks into our agent. So let's go back to our agent.py file. So the first thing we want to do is plug in the before tool callback into our stock analyst. So let's go to our stock analyst here. Now what we want to do is we want to include the before tool. So just after tools here, we can add before tool callback. You can see it already even picks it for us. So before tool callback, we want to add our validate ticker before tool. But first of all, we have to import these functions because they don't exist yet. So right here at the top, I'm just going to paste some code to import the callbacks we need. We need the callbacks for audit log, for disclaimer, and for validate ticker. So we have the one for validate ticker now. Next, what we want to do is to set up the before agent callbacks and the after agent callbacks. Next, we'll go to our root agent, because we want this to run before the root agent actually executes and after. So right here, just under the sub agents, we're going to add the before agent callback and add our audit log. Both of these two callbacks, all they're doing is just printing something or adding something. We're not really modifying things. So audit log before agent. So before any of the agents is called, in this case, our analysis pipeline is going to log that. And after model callback is going to add the disclaimer after the analysis has run. And now we have both of these in place. The next thing we'll want to do is to validate that callbacks are actually working. So I'm going to go ahead and save this file. And once that file is saved, we're going to go ahead once more and start ADK. So I'm going to start ADK again. Okay, now we have ADK working. So let's go back to a browser and launch 1000. Select our agent, WealthPilot. And this time we're just going to type in some text in here and say analyze APL, and let's see what happens. Now we can see this is running. If we look at our terminal here, you can see our ticker AAPL validated. So this tells you that our callback to validate ticker before a tool call is actually working. And we see that it's called here twice because we have two tools here, fetch stock price, get company info. So it's actually calling this before it calls each of these tools. Okay. So now we know, and now we are sure that our callback is actually working. Now next, we can test the ticker symbol validation is working. For example, I can type in a wrong ticker symbol and let's see what happens. Analyze 1, 2, 3. It's going to try to pick 1, 2, 3 as the ticker symbol, but let's see what happens. It should fail. Of course, I can help with that. However, 1, 2, 3 does not appear to be a valid stock ticker because it can actually tell now that our ticker symbol we provided is incorrect. So we know our validation is actually working. And now finally, let's run the full workflow and let's see if our disclaimer is working and our audit logs and all of that are working. So once again, we can say analyze, this time provide a valid ticker symbol for 50K investment over 5 years. Okay, so it started, everything's working, transfer to agent. Now it's asking for a risk tolerance, which we haven't provided. So we need to provide a risk tolerance for it to be able to proceed. So let's go ahead and provide a risk tolerance. Risk tolerance is moderate. Investment period is 5 years. Okay, so you can see our disclaimers right here at the bottom. This is AI generated analysis, not financial advice. So this tells us that our disclaimer is actually working just like we expected. There should be a disclaimer at the end of the processing by the agent. And that's it for this video. I'll see you guys in the next one. Bye for now. Hey all, welcome to this video. So today we're going to be talking about ADK session, state, and memory. Now, ADK uses 3 different mechanisms to ensure context availability and continuity of conversations when you interact with agents in ADK. And this includes session, state, and memory. Session is the conversation thread, while state is the notepad you scribble on during it. So you can think of this like a phone call, and you have a notepad where you take important notes of things that happen within your conversation or during that call. Now that's your state, and it's valid only for current session that you're having. While memory is more long-term storage, so in this sense, you can think of it like a cabinet where you store all your session notes. So this cabinet might include notes from all the previous sessions that you've had with this caller, with this client, and you can reach through that cabinet and pull out notes from previous conversations or sessions, and you can use that information in your current session as well to optimize or increase the usefulness of the value that you provide in that session. So that is what session state and memory is. Now we're going to start by going through in detail to see how session state and memory relate in an ADK conversation. This is what a typical use case might look like. So you have a user who interacts with an agent, and what happens when you try to interact or create a new session is that ADK uses something called a sessions service to manage sessions within a conversation. Now keep in mind, like we said, sessions and state is valid for the context of a conversation, while memory is valid across conversations. So ADK uses something called a session service to manage that session. So it creates a new session object or session database, and that session database is for that conversation thread. It also uses events and states as well to manage and store additional information that's needed for that conversation. Now, when that conversation ends, ADK uses something called a memory service. If you have memory configured to store the most important information about that conversation for long-term storage. So it uses that and stores that in your long-term store. Now, memory service, which we're going to talk about in much more detail later on, ADK has different mechanisms as well for managing memory. And you have in-memory service, Vertex AI, or either third-party database, which we'll talk about later on. Now, when you start a new conversation, if you have memory configured, ADK is going to check the memory service and see, okay, what information exists from previous conversations that I need to pull in. And there are two different mechanisms as well, which ADK uses to decide what information or if to even check for information. There's preload and there's load memory, which we'll also talk about. So now looking at session, which is the conversation container. A session is a single conversation thread between a user and an agent system, like we said, and it holds the full history of messages plus a scratch pad, which is the state in this case, for temporary data. Now, in a typical ADK session, there are different fields which is supported. You can think of this just as a JSON object if it helps contextualize it in memory much better. So it has an ID, which is the current conversation ID. It has an app name, which is the agent name, which is the agentic app name. You have a user ID, which is the user that's currently interacting with that agent. You have the events, which is a chronological list of messages and actions. So events track different things that happen within that conversation with the agent. So this could be you sending a message or the agent responding or tool call. The ADK uses events to track all of those activities that happen. Then you have the state, which is a scratch pad for the agent to store key value pairs of important information. And finally, you have the last update time, which it stores the last time that the session was last updated or the session state was updated. And here you have a sample diagram of the lifecycle, everything we've talked about before. Now, there are also some mechanisms or strategies which ADK uses to determine the context in which certain information should be stored. And the most important concept here is the prefixes. So if you don't provide a prefix when you're modifying the session state, the assumption by ADK is that that key value pair that you're storing is only valid for that particular session, and it's not available beyond that session. So for example, if you're modifying state to store something like risk tolerance, for example, the assumption is that information is only valid for that session. If you use the user prefix, the assumption by ADK is that that information needs to be available across the sessions for that user. So if you create a new session as well, by default, that information will be made available. And then you have app prefix as well. If you use the app prefix, this should be for information that you want available across sessions in the app in general. And you can use this for maybe a disclaimer across app sessions. You want to send a disclaimer across all the sessions. Or you can use temp. This is for temporary data, and this is only valid for invocations. So when you call an agent or when an agent starts processing a particular request, that's an invocation. Now, when you use the temp key to store data within that invocation, that state variable or that information that's stored using the temp prefix is only available across invocations that that agent will do in the course of delivering that request back to its caller. Now, how does states get updated as well? So ADK has multiple ways in which states get updated. You can use an output key when you use an LLM agent to store the final output from the agent. And you can also use tool context. So ADK's recommended way to modify states within a tool call is to use the tool context. So rather than trying to modify the actual session DB or session object itself, you use the tool context or state, which gives you access to modify states from within that tool call. Or if you're calling from within a callback, it also has a callback context as well that's passed along, which you can use to access and modify state from your callbacks. And then you have session service implementations. You have in-memory session service for when you're managing memory locally in development. So keep in mind that when you're using in-memory, which we're going to be using in this video, by the way, whenever you restart the app, you lose whatever's stored in memory because in memory is only valid for that application. Once it restarts, you lose that data. Then you have database session service, which you can use to store your sessions for long-term retrieval, maybe in SQL or PostgreSQL databases. And you can use Vertex AI session service, which is a managed cloud session store by Google, which you can use and plug into your multi-agent systems, giving you a cloud-based session store. Now, cross-session recall is just what happens when a session ends and a new session begins. So if you have a memory configured, when a session ends, ADK takes that session, conversation history, and stores it in memory if you have memory configured. And then when a new session starts, it retrieves that session information from memory, and that becomes available for the agent to search. And like I said earlier, there are two ways in which you can retrieve memory. You can use preload memory tool, and this automatically makes the entire memories available at the start of each turn for the agent. And you can use load memory tool, which sort of abstracts away or offloads the responsibility to the LLM model to decide when to retrieve or use information from memory. So in this video, we are going to look into implementing session storage and state and memory into our WealthPilot application. We're going to be implementing state to store some configurations. In this sense, we're talking about the user preferences for the investment. We're going to store that in state using the user prefix, and when we do that, it's going to be available across sessions for that user. And we're going to use memory as well to recall past portfolio analysis from previous conversations for the user. Now keep in mind that once we restart the app, because we're using in-memory store, we're going to lose all of that information basically. And then finally, we're going to use state for storing risk tolerance. And when we store that in states, only valid for the current conversation. And once we create a new conversation, we no longer have that information. So when should you use state versus memory and all of that? If you need the data for the current conversation only, then state is your obvious choice. If you need data across conversations for one user, then you need to use state, but then you also need to use the user prefix. If you need data across all users, then obviously you go higher up the stack and use the app prefix. And if you need temporary data that's only available within one request, then you use the temp. Remember, when you use the temp prefix, that's only valid for the current invocation by the agent. And then if you need searchable recall of past conversations, obviously go with memory. And if you need raw conversation history, that's stored in session events. And so that's it for now. Next, we're going to dive into building our actual session storage and memory utilities for our WealthPilot application. So let's get into it. So now that we understand what state, session, and memory means, we're going to go ahead and instrument our WealthPilot application with some session storage in state and memory. So first of all, we're going to go into a WealthPilot application and go to tools. Now remember, we have our stock tools here. And the first thing we want to do is to add a save user preferences. So what we want to do is to save the user's preferences in session state and make that available to all our agents. So each of our agents has access to the state. And as a result of that, when you store something in state, it makes it available, remember, within the session. So the first thing we want to do is to add a save user preferences tool that can write to session state. So the user preferences persist within the conversation and other agents can read them. First of all, we're going to add a save user preferences to our stock tools. At the top here first, we're going to import from Google ADK Tools. We're going to import our tool context. Our tool context, remember, gives us the context to use in our tools. Now that we have that, the next thing we want to do is to create our save user preferences tool. And for that, I'm going to go ahead now and paste a bunch of code, which should help us achieve that. And then I'm going to talk through what that code does again. Okay, so now we have our save user preferences tool added. This is again another simple tool. We're passing in tool context here, which ADK allows us to, and we're setting some parameters for this tool: risk tolerance, investment budget, and investment horizon, which is a string. Now we have our docstring here as well, and we're saying this tool saves the user's investment preferences to session state. Defining the arguments, remember, very important for the agent to know what each of these parameters are. And the return value as well. This tool is going to return a JSON confirmation of saved preferences. And then you can see we're utilizing tool context to access state and modify state. So we're setting values for risk tolerance, which is the risk tolerance provided by the user, the investment budget, and the investment horizon as well. Okay, so finally, we're returning a JSON dump here with those values. Now, this is just preference, but you can decide to not return this. Something else you can do is to just return none, since you've already modified state here as well. That should work as well. Okay, so now that we have that in place, I'm just going to save that file. The next thing we want to do is to integrate or import this new save user preferences tool into our agent.py file. So our agent actually knows about this tool and can utilize this tool for its activities. So let's go back to our agent.py, and right here at the top where we have our tools declaration, we want to add the additional save user preferences tool, which we just added. Now, once that's in place, the next thing we want to do is to make our agent aware of this new tool that we just created. So we're going to go down to our root agent. Now we want the save user preferences to run basically after root agent starts. So the root agent needs to be aware that we have this tool. So in our root agent, which is an LLM agent here, we want to define tools that are available. We have some agent and our callbacks. We want to define tools and set the save user preferences as well. Once it gets all those requirements from the user, it's going to call our save user preferences. Now for it to know when to call our tool, we need to update our instructions, our agent instructions. That's what we're going to do next. We're going to add a new item for save user preferences. And I think for that, I'm just going to set that to a third option. So add a new option here for 4. And for 3, I'll say save user preferences using save user preferences tool. Okay, use save user preferences tool once you have the info. So once it has all the information, it's going to call our save user preferences tool to save the information. So I'm going to save that. Okay, so once we have that saved, the next thing we want to do is to make one of our agents aware of the data that we're storing in state now. And in this case, let's do that in our portfolio advisor. So we want our portfolio advisor to be able to utilize this information that we're storing in state now. So we just want to tell our portfolio advisor that there's new information in state that you can use. So I'm going to make some modifications here as well. And I'm going to add these 2 new lines. So here we're saying use the user's risk tolerance and investment horizon. We're relying on the agent or the LM to be able to provide or pass that information over to the portfolio agent. So now we're going to explicitly tell it that we have a tool and that we have this information stored in state, and they can take advantage of that and just use that. I made some update here. So you are the portfolio advisor at WealthPilot. Your job is to recommend portfolio allocations based on, now we're saying the stock analysis provided by stock analysts, of course, and the user's preferences from session state. Check for risk tolerance, investment budget, investment horizon. So now we're making the assumption, not an assumption because technically we know that exists because we're storing it in state. And we're storing that information and we're telling the portfolio advisor agent to check the states and get those values from state. Now that we have all of that in place, I'm just going to save that. We're going to go ahead and start ADK, and then we're going to test out our new implementations. So I'm going to go ahead here again and run UV ADK web to start our agents. Okay, so now that's started. So I'm just going to go ahead here and start a new session. This is from our previous session tests. 8,000 again. We're going to select our WealthPilot agent. And this time around, I'm going to just say something like, I have 50K to invest and moderate risk, 20-year horizon. Now what I expect is, with this information, it should have all it needs to be able to call those tools to assist the information in our state. Now you can see the first tool that's actually called is our save user preferences. So it's using our tool to save that information just like we expected. So I'm going to click on that and let's see what save user preferences actually is. And you can see here that it's actually storing our preferences. So you can see our risk tolerance is moderate, investment budget 50K, which we provided, investment horizon 20 years, and it saved that information as well in our state. So just like we expected, and if I click on state, we should be able to see key value pairs for what we just thought: risk tolerance, investment budget, and investment horizon. So we're sure that our tool is actually working, just like we expected. We just saw that our state is persisted. So the next thing we want to do is let's see if our portfolio advisor has access to the information. So if I say something like, let's say analyze AAPL, and our portfolio advisor should have access to that information that we provided earlier. Okay, so we have its fractional stock price, and let's see what it does with the information that we have earlier, and let's see if it knows about that information. So here it's calling a transfer to agent, and then it's fetching a stock price, getting company info, APL, and all of that. Okay, so we have thank you for sharing, blah, 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 blah. And we can see that it knows about our investment budget. You can see here it's using our investment budget that we provided earlier. So it has the information from state, which is 50K. And it knows about our risk tolerance as well, which is moderate. So we're sure that it's actually getting that information just like we expected from our state. Okay, so now we can see that agents are able to assess states or information from our state just like we expected. Okay, so WealthPilot call tools give you preferences, and this is what from our previous invocation. So that's it for this video. We've seen how to utilize session states to be able to store information that's persisted across the session. And we've seen how we can have our agents in the same session have access or read and write information to state. So now that we understand how session state and memory work, and we have seen how to implement session state, next, we're going to look at how to implement memory. And our goal for this is to be able to have memory persisted across sessions. So when we provide some information to our agent in one session and we start a new session, we expect our agent is able to recollect the information we provided to it from previous session. And we're going to be using in-memory service for this. So to add this implementation, the first thing we want to do is to add a memory save callback. So what we want to do is after our session or invocation with the agent, we want our agent to save that conversation information in memory so that when we start a new session, it's able to recall and load that information. So back here in our callbacks, we're going to go to Guardrails, the PY, and in here, we're going to add a new callback, and this callback will be to save to memory. So I'm just going to paste in some code in here and can explain what that does, so don't worry. So this is our after agent save to memory callback. So what we're doing here, we're just assessing the callback context. Now remember, the callback context, the agent doesn't need to know about it, but it's provided by ADK automatically to those callbacks. So we have our callback context, which we can access state from, and the callback context has the add session to memory method. So we can actually assess or store something to memory via the invocation context of the agent without having to go through the session itself or directly accessing the session object. Okay, so our doc string here says saves the current session to memory after each agent run. So here we're now saying await callback context, okay, dot add session to memory. Now this should package the existing session and save it to memory and then print out this on our CLI. And we're returning none because we don't want to impact the execution flow of the agent session. I'm going to save that. Now, once we have that saved, the next thing we want to do is to go to our agent.py and now add the necessary instructions and also the necessary callbacks to our root agent so it knows about how to use this callback. So we're going to go back to agent.py. And back in agent.py, the first thing we want to do is to add the load memory tool to the root agent. First of all, let's import it because we don't have a use anywhere else. So the first thing we want to do is actually import it. So here from the top of the file, I'm going to go from Google ADK tools load memory tool. We want to import the load memory tool. So once we import our load memory tool, next thing we want to do as well is to import our callback. So we're going to import our save to memory after agent callback, which we just created. And then back in our root agent, here we're going to add the tool because it needs to know about our new tool, which is the load memory tool. So this tells ADK that our root agent has access to the load memory tool, which it can call. We're going to update our instructions as well to tell our agent to first load memory, in which we already have here. So we're saying use load memory tool to check for any past preferences and load that into the conversation. And then we're telling it to use the load memory tool. And then something else we want to do as well is to provide our callback. So we want to provide the after agent callback, save to memory after agent, okay, which is the callback we just imported here. So now that we have all of that in place, we should be able to save and then do a test and see if everything is working correctly. If everything is working correctly, we should be able to recall conversations across sessions, and we should see a log of that information getting saved. So I'm going to go ahead here and spin up ADK. So starting up the ADK web server again, go to the browser, localhost 8000, just to refresh, and we're going to go to WealthPilot. Okay, everything is running correctly. And now what we're going to do is, hi, I'm a conservative investor interested in dividend stocks, like let's say KO, Kohler, and PG. Procter & Gamble, for example. And let's say I have $50K to invest with a 10-year horizon. Now, let's say I want this and I provide this information to my agent. What we expect is that it should save this information in memory after it's done with its invocation. So it started processing. And again, we have our save user preferences. If we go to state, we should be able to see the information we just provided. Okay, so now, would you like to proceed with detailed analysis and long-term profile? Yes, proceed. So let's proceed. So it has the entire interaction run through. So it calls a stock agent, calls our portfolio analysis agent, provides us a report, which we want, because we want the entire agent workflow to run and then persist that information to memory, which is the last thing that should happen based off of where we've placed our after agent callback. Okay. All right, so now we have a full invocation run. If I go back to the terminal, you can see here, we have a new line here. Interesting. It says memory, saved memory, session saved to memory after WealthPilot. So now we can assume, based off of this, that a callback is being called and it's saving that information about that session to memory. So if we go to a new session now, and in that new session, I say, what tags have we analyzed recently? Let's see if it's able to remember now. Okay, so load memory. So it's actually loaded memory now because we added that step for it to load memory. So based on our previous conversation, we recently performed a detailed analysis of Coca-Cola and Procter & Gamble. So now we know that our new session has access to information that we stored in the previous session. So by this, we know that our actual cross-session memory access is actually working. And that's awesome. That's all for this video. I hope you found this helpful. And in the next video, we're going to be talking about code execution. So see you in the next one. Bye for now. So let's talk about code execution. Code execution in ADK allows your agent to not just generate text, but also run computations, actual computations, produce results of those computations, and use that information in its response to you as a user of those agents. So instead of having to write deterministic code yourself using tools and all of that and define parameters that has to be passed at every stage, you can allow your LLM agent to generate that code and then run that code in secure sandboxes that ADK provides, and then use the result of that as you will in your computations. So in this case, you can think of it like providing a scratchpad for your agent. So instead of it's just guessing what certain computations are, or having to use your tools where you have to pre-write the code and the computations yourself, you can just tell it what computations are needed, and it can also decide on its own if it needs to do any computation. It can get that code from the LLM agent, and it can run that code and produce the results. So what the workflow looks like is, say for example, you use a queries the agent and say calculate compound return, for example, for 8% for 20 years for 50K. And that query gets forwarded to the LLM model. The LLM model decides that it needs to generate some code to calculate that compound return. So it generates that code, but nowhere to run the code. But if you have a code executor, what happens is that generated code is then run while the LLM agent generates the code, and then the code executor engine now runs the code and produces those results, which is returned back to the LLM, and it can use that to properly make its decision or formulate its response. So in ADK, there are 5 different code executors. The first is the built-in code executor, which is built into Gemini itself. So if you're using the Gemini group of models, especially after Gemini 2.0, you should have a built-in code executor. You just need to make sure you have your API keys in your .env file. And what happens is if the LLM model generates certain code, that code will run in the built-in code executor. And then you have the container code executor. This is a local Docker container which you can define, and you need to make sure you have Docker Desktop installed and can run containers locally. This is also just for local sandbox testing or execution. You don't want to run this in a production environment. You probably just want to use this locally when you're testing. And then you have unsafe local code executor, which is the list of the list, and I wouldn't recommend using this at all for security reasons, obviously, but this just uses exec to execute code locally on your machine. No sandbox whatsoever. And then you have Agent Engine Sandbox Code Executor. This is a much more managed code execution interface that's provided by Google Cloud in Agent Engine, so you can use that as well, which is much more what looks like what you will want to do if you're running production agents. I'll definitely recommend going with Agent Engine Sandbox. Or you can use Vertex AI Code Executor as well, which is also GCP provided, and you can use that to run your code. So what does the built-in code executor actually do? Like we said, Gemini generates code, the executor runs the code, returns the result to the model uses that to formulate a response and returns back to you. Now, there are some limitations when it comes to using code executors in ADK, and the main limitation is that you can't use a code executor tool with multiple other tools. It has to be single tool per agent rule. So when you're using a code executor, you can have other tools alongside in the same agent. And we're going to see that, for example, in our WealthPilot application. So you can see we're only defining code executor. We can't use any other tools here. Now for container code executor, likewise, the code is generated by the model, and then it spins up the Docker container, and the container runs the code, and then the output is returned back to the model again. And this time around, we just declare the Docker image we want to use, and it's going to use that. What are some differences between built-in code executor, the container, and the custom tools? All those are here for you. So now let's proceed to integrating code execution into our WealthPilot multi-agent system. What we're going to do next is we're going to be setting up a financial calculator sub-agent. And this sub-agent will be responsible for dynamically computing compound returns, projections, and any other portfolio math that the agent needs to perform. And we're going to be running that live on ADK Web. So let's go ahead and build. So now that we understand how custom code execution works in ADK, we're going to go ahead and implement some custom calculations for our WealthPilot application. Now in this case, we're not going to be using our custom built-in executors or the Docker executor, because the built-in executor actually conflicts with our setup, because we have a multi-agent setup where we have the transfer to agent tool, which is automatically transferred by our agent or our root agent to the sub-agent. So if we set up our calculate compound returns sub-agent, in this case, it's going to conflict with the transfer to agent tool. And keep in mind that when we're using our code executor, it's one single tool per agent role, so we can't mix them up. So for that, we're going to be using tools to execute the calculations that we need. So let's get to it. So the first thing we want to do is add new tools to perform deterministic financial computations for our compound returns and our portfolio allocation. Back here, we're going to go again into our tools directory. And this time around, we're going to create a new set of tools. I'm going to call this calc tools.py. Remember, we have stock tools, which we created earlier. This time we have calc tools. I'm going to paste a bunch of code next and then talk about what it does. Okay, now we have our code in here. And again, this is just our standard set of tools, acceptance and parameters. We have our docstring, we have our arguments, and we have our returns. And in this case, we're taking arguments for the principal, for the annual return percentage, and the years, which is the number of years we are projecting for. And this will just return JSON with a yearly breakdown of our financial balance or our final balance for each of those years. So we're just doing a calculation here where we're looping through for each of the year. We're looping through and then using the balance to calculate the interest. And then so the balance times the annual return percentage of 100. And then we're adding the interest to the balance and then computing the yearly breakdown. So we're just appending it into a JSON object here for each of the years that's available, and then returning that JSON. And then the second tool we have here is the calculate portfolio allocation, which will just calculate the dollar amounts from the percentage allocations. So let's say in the case where we have multiple stocks being analyzed, let's say Apple or Microsoft, for example, and we want to maybe split our allocation between those stocks. In such cases, this tool will actually calculate the actual dollar amounts for each of those allocations. Again, we have our docstring, we have our argument, and we have our return values. And here we're just using try to make sure, which is best practice for tools, by the way, to make sure you're able to catch any errors that's happening. And we're loading that in and then performing our computation and then returning a JSON dump of the values based on the computation that we just done. So now that we have our tool ready, we're just going to go in and integrate or wire in calculation tools to our portfolio advisor, which is where the actual analysis happens. So we're going to go back to hn.py file, and right here at the top, we're going to include the tool. So from calc tools, we're going to include calculate compound returns and calculate portfolio allocation. After importing those tools, the next thing we want to do is go ahead and tell portfolio advisor about those tools. So portfolio advisor, we want to go and set up a new tools field. We don't have tools here for portfolio advisor. So we're going to go in and set up tools. And now portfolio advisor has calculate compound returns and calculate portfolio allocation. After that, we want to update our instructions as expected, so it knows when to call those tools. So I'm going to add a new line here, just under the guidelines. Use your tools, calculate compound interest to project growth over the investment horizon, and calculate portfolio allocation to compute dollar amounts for each position. That's all we need, and then it will use those tools accordingly to do the necessary calculations that it needs. So now that we have that in place, I think all we need to do is to just go ahead and start ADK Web and test it out. So let's go ahead and run ADK Web again. Okay, we have ADK running, so let's go back to a browser again, and this time around we just refresh again. And this time around, let's just give it a use case. So I'm going to select my agent, WealthPilot, and if I have 50K at 8% for 20 years, what will I have? Let's see what happens. So it's running. Of course, I can help you with that, assuming 8% return is compounded annually. After 20 years, your initial investment of 50K will grow to approximately 2333333. Now, would you like me to analyze some specific stocks or help you build a portfolio based on your financial goals? Now, it seems to be doing some calculations, but we don't know if it's using our tools for that. And I don't think it's using our tools for that because right now, it's stuck on the WealthPilot, so it's not really calling our tools yet. So for us to be able to get that, we need to give it a stock to analyze, because the portfolio advisor is in our sequential agent. And what's happening right now is the LLM itself doesn't know about those tools, and it's not even getting to the analysis pipeline. So there's no way it's even going to know about our tools, right? So we need to first pass through these pre-requirements. So in that case, we need to give it some stock to analyze, and then it will do the computation, which is what we actually expect. So analyze APL and MSFT for 50K dollars investment over 5 years. Oh, let's do that. Such one, and now again. Okay, so it's transparent stock analyst. Okay, now we're progressing. Stock analyst got us some returns, and then portfolio advisor was called. So now we can see it's using our calculate portfolio allocation and calculate portfolio returns. And you can see here that we have a whole bunch of data based on our principal and our interest earned for all the years. Since we gave it 5 years, it's calculating that for 5 years. And compound returns likewise is also doing its own calculation, like calculate portfolio allocation is also doing its own calculation. So we can see calling tools basically to have those calculations done. And here from the trace, we can see that our portfolio advisor is calling calculate portfolio allocation and also calling calculate compound returns. If we click on calculate compound returns, you can see that's the trajectory that happens. So this is a return of the value after calculation has been done. And in our final output here from portfolio advisor, you can see it includes detail of all of those calculations. So we're sure now that our tool is actually doing some actual computations, which is awesome. And this further enriches the final portfolio analysis that we get, because we get a full breakdown of the price just by including these new tools to do those calculations. So that's it for this video. I hope you've learned something. In the next video, we're going to be talking about artifacts. So I'll see you in the next one. Hello. In this video, we're going to be talking about ADK artifacts. So what are artifacts in ADK? Well, artifacts allow us to manage named version binary data within and across our conversations. So this means artifact let our agent or our tools create, save, and version files. And these files that we create and save can be CSVs, PNGs, which are images, or PDFs, as the case may be. We can generate all sorts of images or binary data and store them as artifacts in ADK. Now, so we can think of artifacts like the more larger scale version of memory. So while memory allows us to be able to store conversational history across multiple sessions, artifacts allow us to be able to store larger scale data across our conversations or within our conversations. The analogy here is you can think of artifacts just like filing cabinets for your agent. So each time it generates a report or some useful artifacts, some binary data, images, etc., it stores those in the filing cabinet, files it under a certain name, and versions it. And then when it needs to retrieve that information later on, it just goes there and retrieves the information based on the version that it's stored it under. And every time you create a new file or a new artifact with the same name as the previous one, it overrides the previous one and creates a new version. How does artifact work in the agentic workflow? It's very straightforward. A user chatting with an agent says something like, maybe generate my portfolio report, and the agent has the skill set to be able to generate a portfolio report. And this report could be Markdown or PDF as the case may be, but whatever it is, the agent uses its tools or whatever skills it has to build that report. And then you call the save artifact, which is available either on the tool context or the callback context, depending on where you're accessing the save artifact from. And you call back and save that data. In ADK, artifacts are stored using the artifact service. It's a specialized service in ADK that ADK uses to manage the storage and retrieval of artifacts. How does artifacts differ from state and memory? We sort of hinted at it earlier, but basically, we know that state stores key value pairs, while memory stores conversation summaries, and artifacts store files, binary data. Scope is also different because the scope of state is within the session, memory is across the session, while artifacts can be stored within the session and across sessions for the user. And then sizes, while artifacts are designed for large scale data, so PDFs, images, CSVs, and other forms of binary data. And artifacts are also versioned, while state and memory isn't necessarily versioned. And then you have access to the save artifacts and the load artifacts methods, which you can use on the context. While in state, you use key value pairs, and memory, use the load memory tool or the preload memory tool. And then artifacts are best for, say, reports, exports, uploads, and any additional data that your agents or your tools generate in the course of the interactions that might be useful to the user later on. Now, the core concept of how artifacts are stored is using the data type from Google.GenAI.types.part. And this is a similar data type to what ADK uses for messages as well. So you can access it from the Gen AI.types.part and use that to build your artifact, and then just store it by specifying a name for the artifact as well. So retrieving artifacts is a matter of just calling load artifact and the name of the artifact and the version, if you have a version for it. Now, namespacing, just like state data, artifacts also support namespacing. So if you just specify a name for your artifact, it is assumed that artifact is only available for the current session. However, if you namespace your artifact name, so using something like user, in this case, that artifact is available for the user across sessions. Now, like I said earlier, in ADK, you have two main classes will help you manage artifacts. You have in-memory artifact service. This is just like the in-memory memory service, which helps you just store data in RAM. And once you reload the application, all of that information is gone. This is the same as well for artifacts. And then you have the GCS artifact service, which is a managed storage service based on Google Cloud Storage that Google provides for your production workloads. So now that we understand what artifacts are and how they work, we're going to go ahead and implement an artifact storage for our portfolio report from the WealthPilot application, which we've been working on in the past couple of videos. So what we're going to do here is we're going to implement a safe portfolio report tool. And this tool is going to store an artifact. In this case, we're going to be starting with Markdown format to store our generated report in a Markdown format using the save artifact methods. So let's get into it. Now, what we're trying to achieve here is to enable our report generator agent to be able to save portfolio reports as versioned artifact files using ADK's artifact system. And to do that, the first thing we want to do is to create a tool, because we're going to be using tools as well here. We've created a couple of tools in the past, card tools, stock tools. Now we're going to create a new tool, and this tool we're going to call report tool. I'm going to pluralize it in case we need to create multiple of them, report tools, since that's the format we've been using for the other tools as well. And then I'm going to paste a couple of code in here and then talk about what exactly they do. We have our safe portfolio report. Once again, we're importing tool context from Google ADK Tools. And this safe portfolio report tool accepts some parameters for the report title, for the report content, and tool context. And we have our docstring as well that describes what the tool does. And we're setting arguments for report title and report content. And then our return here is a JSON confirmation with file name and version number. Okay, so we're initializing a timestamp variable here and setting the full report string, doing some interpolation here with some strings and the timestamp and the report content that was provided. And then finally, we're setting a disclaimer here to say this is an AI generated analysis, so not financial advice. And then finally, a closing remark powered by WealthPilot built with Google ADK. And then declaring an artifact. Remember, we said you can build your artifacts using the Gen AI.types, which we're importing here, importing types here. And then we're using types.part from text to build our artifact. And then finally, we're saving the artifact using the tool context, which is provided for our tool. And then setting the name to portfolio report.md. Now take note that we're not using any user namespace or any prefix for this storage. So it's only going to be available for the course of our current session. Then we're providing the artifacts that we want to store. And then returning a JSON object with key value pairs for the report that we just generated. Now, something to keep in mind here is you'll notice that our function, or our tool in this case, is an asynchronous tool, and that tells ADK that we want to create this function to run asynchronously. Otherwise, we'll get an error about serialization. Now, keep in mind, tools in the ADK, the input and output has to be fully serializable. So now that we have all of that in place, we can go ahead and wire up our report tool into our agents.py file. Let's go ahead and do that. The first thing we want to do back in agent.py is going to be to import our newly created tool. Okay, so we're going to come here and from tools to report tools, import save portfolio report, which is the name of our tool. And then in our report generator, which is right here, report generator, well, here we're going to specify the tool that we have. So actually our report generator doesn't have any tools yet, which is nice. So we can go ahead and just plug it in. Tools equal to save portfolio report. And after that, if we restart ADK or start up ADK, we don't have it running already, we should be able to see our report working. Well, actually, now that we've integrated the Save Portfolio report tool, we actually need to tell our report generator instructions. Now, don't forget, we always have to update instructions to tell our report generator that it can use the report or Save Portfolio report tool to save the artifact or our generated report. So let's plug that in. So after it does executive summary, create a comprehensive portfolio report, including executive summary, including stock analysis, recommended allocation, risk assessment, format your output in Markdown, and all of that. Now, before that final step, we're going to tell it to save. We're going to add a fifth step here, and we're going to tell it to save the report as a version artifact using Save Portfolio Report tool. Okay, so now it should be aware that we want to save the report once it's generated. So now I'm going to go ahead and spin up ADK web one more time. Here we have that running. Now we go back to a browser and we're just going to refresh localhost 8000, select WealthPilot. And this time around, let's run the full workflow actually. Let's say analyze APL, Apple stock, for a 50K investment over 4 years this time around. And let's say moderate risk tolerance. So we can see our agents spinning into action and working, and our stock analyst has done some analysis already. Our portfolio advisor has gone ahead and started working as well, and we have a portfolio analysis report ready. And let's see, save portfolio report was called, as we can see here. I don't mind the UI glitch in there, but we can see save portfolio report was called, and we have an artifact that was generated for us. Portfolio report MD generated an artifact. I've generated comprehensive portfolio report for this. The report includes this, and this. The report has been saved as a version artifact with title portfolio analysis report APL investment. And we can see the report was actually saved from the instruction that we see here. Okay, and if we click here in the event, we can see there's an artifact delta, so there's a change. Portfolio report, the MD was generated. And let's click on artifacts, and we can see we do have a portfolio, the MD file here that was generated for us. So that's awesome. So that means our artifact generation is actually working. So as an additional bonus, we're going to take the report we generated previously and we're going to make it into a PDF. So it's easily downloadable or viewable from our browser, and we can actually see the report itself. Doesn't make a lot of sense to just store a Markdown file that we can view from the browser. So what we're going to do next is use our PDF tool to actually generate a PDF report in our browser. So first thing I'm going to do here in our Py project, I'm going to go ahead and add a new dependency in there. It's going to be the fpdf2 library, which we're going to be using to generate our PDF. So make sure you have that in your dependencies. And once you have that, I'm just going to run UV sync here to make sure I have my dependencies in place. Regenerate my log file, fpdf. Okay, now that I have that in place, I'm going to go back to our report tool here. Now, fairly quickly, I'm just going to replace a whole bunch of text that we have in here with a different function. And this is the function which we are going to use to generate the PDF report instead of the text or Markdown based report. Nothing else has to change besides just the code in this tool. So you don't have to worry so much about a lot of things changing. Nothing else is changing, just the function that actually saves or generates our report. So I'm going to replace the entire file. And now we have PDF report generation using ADK artifacts. So I'm going to save that file. And basically what we're doing here, we're just doing some cleaning for the Markdown. And then we're doing a build of the PDF and doing some checks as well. It's a bit messy, but it actually works. So we're going to use that to generate a PDF. So it's a bit messy, but it actually works in generating the PDF. So we're just going to use this to generate our PDF. Basically, it still takes the report title and content and then uses that content to build a PDF report, title, content, timestamp, and everything. And then finally here, you can see now we're using from bytes instead of from text. So from bytes actually generate binary data and pass in the PDF bytes, and we also need to specify the MIME type, which is what tells ADK or artifact service the type of binary data that we're storing. In this case, is artifact/PDF. And version as well, we're just saying save portfolio report or PDF. So if it exists, it's going to create a new version. All right, so I'm just going to save that file. And then we're going to start ADK web and then run through the flow again. So once again, UV run ADK web. Okay, that started back in our browser, localhost 1000, and then just hit refresh. And then we're gonna select our WealthPilot, analyze, say PL for 60K investment over 5 years. This time around, let's see what happens. If everything goes well, we should see a PDF report generated for us at the end of the day. So let's see. Okay, now we need to specify our risk tolerance, moderate. All right, so we have a full report, and let's see if it calls our save report. Whoa, there you go. Save portfolio report. We can see we have an application, a PDF file generated for us. And when I click on it, once again, we have our full PDF report. So this makes a lot more sense to me, much more useful. We can see our tool for projection is working. It's calculating the returns for each of those years. Our disclaimer is working and everything's working as expected. Awesome. So that's it for this video. I'll see you guys in the next one. So in this video, I just want to quickly talk about planning in ADK. So sometimes you have really complex requests that actually require a bit of pre-planning before jumping into execution. Now, most state-of-the-art models today actually support thinking out of the box. However, ADK actually provides us with a base planner which you can actually utilize to enable multi-step thinking or reasoning and planning before action. In ADK, there are two ways in which you can utilize planning. So you can either use the built-in planner, where we just need to configure a thinking budget. As long as the underlying model supports thinking, ADK will ensure that our thinking budget is propagated to the LLM, and the LLM uses our thinking budget to actually do some pre-planning before it begins execution. However, in situations where you're using a model that doesn't support thinking, you can actually use ADK's React Planner. It's a bit more complicated, but the structure is the same. So for this video, very quickly, I'm just going to instrument the built-in planner where we'll set a thinking budget for our LLM agent. And we're going to do that for our root agent here. And let's see how that actually impacts the behavior or the workflow of our WealthPilot agentic system. So to do that, the first thing we want to do is to just go into our LLM agent here, which is our WealthPilot. And we're just going to add a new parameter in here. And that's going to be generate content config. And this is of types that generate content config. Okay. And we're going to set thinking config in call to types of thinking config. And in this case, we want to enable thoughts correctly. And we want to set the thinking budget in this case to 2048. So just a decent amount of tokens that we want the LLM agent to use for pre-planning or thinking, okay? So we have types, so let's just ensure we're importing types somewhere here at the top. If we're not doing that, we need to do that. So I don't see types imported here. So let's make sure we import that. So Google the Gen AI import types. And now we're using generate content config to set a thinking budget. Once you're done with that, just save that file. First of all, let's just make sure we fix this. This should be thinking budget and not thinking budget tokens. So thinking budget is 2048. Just gonna make sure we save that, and then let's start ADK web. If everything goes correctly, we shall see our agent doing some pre-thinking this time around. So I'm gonna go ahead and reload on port 8000 select our WealthPilot agent, and this time around, we're going to give it a fairly complex prompt or input and see how it handles it. So portfolio, and hit enter. Seems to be taking a bit longer, so I assume it's actually thinking. Okay, look at that. We now have our WealthPilot agent actually doing some pre-thinking. And we can see the thoughts shown here because we enable include thoughts. So you can see it's showing us here the pre-analysis that's doing. Okay, here's how I'm thinking through this, and new users requesting return. So it sort of goes through and in detail try to analyze the request and build up a plan before it starts execution. The impact of this is that we'll have a much more structured or better outcome at the end of the day. So if we compare the final outcome here and what we had previously, we might see slightly better improvements. If the thinking is actually useful, which in most cases it is, but in general, we can see the thought of our agent here, and we know that it's actually doing some pre-thinking and pre-planning before executing. Okay, awesome. So that's it for this video. I'll see you in the next one. So now if you remember in a previous video where we talked about the architecture we're going to be building, we did talk about parallel agents and how parallel agents can help us run agents simultaneously. So what we want to do in this video is see if we can implement parallel agents and loop agents to sort of optimize or improve the flow of our WealthPilot agent system. And what we're trying to achieve is a way for us to analyze multiple stock in parallel as opposed to the sequential stock analysis that we have right now. And we are going to use the loop agent as a checker to ensure that the portfolio analysis that's done matches our risk tolerance. And if it doesn't match our risk tolerance, we're going to use a loop agent to continually run an iteration. Now let's get into it. This is going to be straight up implementation. So back in our agent.py, the first thing we want to do is add two new workflow agents, one for a parallel agent. So add in workflow agent, so deterministic, and we're going to add one for parallel agent and one for loop agent. The first thing we want to do is to import this new agents that we want to use. So here we're importing sequential agent and LM agent. We're going to import loop agent as well and parallel agent. Now we're going to paste in a bunch of code, and then I'm going to explain what that code does. So what are we doing here? We're creating parallel stock analysis to be able to analyze multiple stock in parallel. And how we're doing that is by creating three new LLM agents, Parallel Analyst 1, Parallel Analyst 2. These are sub-agents that each can analyze stocks, and Parallel Analyst 3. They can all be tasked with analyzing stock. And here you can see we're saying analyze, the description is analyze the first stock in a parallel batch, analyze the second stock, analyze the third stock, and we're setting instructions here. You're a parallel stock analyst, analyze the stock assigned to you using fetch stock price and get company info. So each of these LM agents have access to fetch stock price and get company info tools, so they can use it to fetch information for the stock that they want to analyze, okay? And then before tool callback, validate ticker again, just like we're doing previously. So now that we have these three new analysts, we're also creating the parallel agent pipeline here, or the parallel agent workflow, where we're passing the sub-agents, parallel analyst 1, 2, 3. And the description here is we're telling ADK that this is a parallel agent that analyzes multiple stocks simultaneously for faster results. So with that all set, we can now add our loop agent, which we want to use to check that our risk tolerance is being respected. To implement that, since we're analyzing three stocks at the same time, all three analysts run at the same time, three stocks sequentially equal to 3 times the speed. So we're going to save the time it takes us to analyze three stocks. So let's add our portfolio optimizer loop now. I'm going to paste in a bunch of code again, and then we're going to go through what it does. Right here, just after the parallel stock analysis, we're going to paste in a bunch of code for our portfolio optimizer. Now this time we were saying allocation proposer. Its job is to propose a portfolio analysis for us. So it proposes portfolio allocation percentages, and based on the stock analysis of the user's risk tolerance from state, propose a portfolio allocation. and we're providing a format of the data which it should provide for each position. If risk checker asks for adjustments, incorporate your feedback. So this is a looping agent, and we're defining that here where we say loop agent. And we're saying iteratively refines allocation until it matches our risk tolerance. And the sub agent, it has the allocation proposer and it has a risk checker. So what's going to happen here is ADK, when it runs this loop agent, is going to continually do an allocation proposition until our risk checker condition is met. If you remember, we talked about defining a condition for which the loop is exited. If you don't define a condition, the other way you can do it is to specify a maximum iteration number, which is the maximum number of time that you want the iteration to run, so your allocation proposer. In this case, we're using a conditioner here, which is a risk checker, which validates that our allocation matches the user's risk tolerance, and if it does, it exits the loop. So you can see our guidelines here. We're saying if the risk tolerance is conservative, max 40% stocks, and they prefer ETFs and bonds. So providing some guidelines around the user's risk tolerance. With all that in place, the only thing we need to do next is to plug that into our root agent, to tell our root agent how to go about with the portfolio analysis. For that, we're going to add the parallel stock analysis. Parallel stock analysis in the portfolio optimizer. And then, now it knows about the sub-agents. Now we need to tell it when to use those agents. So you have a team of specialists, specialists to help you. And we're going to add parallel stock analysis, analyze multiple stocks simultaneously. So when it gets multiple stocks, it's going to use our parallel stock analysis for that. It's going to use our portfolio optimizer to iteratively refine the allocation until it matches the user's risk tolerance. So now that we have that, I'm just going to save it again. And then we're going to restart ADK. And we're going to provide it multiple stock to analyze this time around. And let's see how it handles it. Looks like we're good. No syntax errors. So here we're just going to start a new session. Again, select our WealthPilot application. And this time I'm going to say something like analyze. Let's give it 3 stocks and see what happens. APL. Okay. MSFT and Google simultaneously. Let's see what happens. Remember, we have a thinking budget. Okay, there you go. You can see all of this happening, all of this running. Our parallel analysts are kicking off. Parallel analyst 3, parallel analyst 2, parallel analyst 1, all kicked off. And each of them handled one of the stock. As we can see, parallel analyst 1 was responsible for Apple. It got Apple. Parallel analyst 2, what stock did he get? He got Microsoft, MSFT. And parallel analyst 3 got Google. Okay. And if we look at the image here, we can see that we have all of these agents kicking off in parallel and doing the work. So we're saving 3 times. We're optimizing by 3 times because we're able to perform the analysis of those 3 stocks 3 times faster. Okay, so parallel analysts 1, 2, and 3 kicked off at the same time, and each of them analyzed some stock using the tools that's required. And after that, it called our portfolio optimizer. So let's take a look at our portfolio optimizer, which was called afterwards. And we can see the results from each of the analysis here, okay, which is awesome, right? And then it called our parallel analyst 3, parallel analyst 3. And what happened afterwards? APL is currently trading at this, slightly down from this. The company boasts significant market. So now let's test our loop agent, which is our portfolio optimizer here. And to enable that, we're just going to add a new instruction here, and we'll say, yeah, when they want portfolio optimization, please transfer to portfolio optimizer. Now, I'm going to save that, and I'm going to restart ADK here. Okay. And then in a new session here, we're going to tell ADK to analyze, let's give it 3 stocks again, APL, MSFT, and Google simultaneously. And we're going to give it some more information. How do you spell simultaneously? And let's watch it do the parallel simultaneous analysis. Okay, we have our parallel analysis running again, and quickly we have the analysis done. So now that that's completed, what we want to do next is take that analysis and tell it to build us a portfolio. I'm conservative with 50K budget. Build me a portfolio. Okay, now let's watch it build a portfolio. Once it builds the portfolio, we're going to tell it to optimize the portfolio. Okay, it needs our investment duration. Just going to say 4 years. Now, if you look at the plan here that's generated carefully, you can see it's building a new execution pathway from our planning. It says then and only then can I actually start building a portfolio. Given the request, the best agent to handle this is the portfolio optimizer. Okay, so that means we will see a call to a portfolio optimizer. So allocation proposer, you can see it's calling allocation proposer to propose, and you can see this being called multiple times. Based on your conservative risk profile and a 50K budget, here's the portfolio allocation across these 3 technology stocks. And the risk checker, you can see our risk checker running as well. And its suggestion is we need an adjustment because our allocation of 100% in individual stocks is too aggressive. Based on the conditions that we've said that were conservative, it has to optimize the portfolio again. So it goes back to allocation proposer, and allocation proposer proposes and finally comes up with something, and risk checker checks again. And this time, risk checker approves it because the allocation matches our conservative profile. And once that's approved, we have our completed profile. So what is the completed profile? Just wanted to print that all out for us, even though it already shows it here. You can see Microsoft 16%, Google 12%, and APL as well. So finally, we have a complete portfolio. Microsoft 16%, Alphabet, Google 12%, and 12% Apple. And that's our optimized portfolio. So that's it for this video. We've seen how parallel and loop agents actually work and can help us optimize our agentic workflows. I'll see you in the next one. Bye for now. Hello folks, and welcome. So in this video today, I want to talk about the ADK runner for a bit. Now, if you remember in the previous video, we did talk about how the runner is one foundational component of how ADK works. So in this video, we're going to go multiple steps deeper into seeing how the runner actually works and what it does. So the runner is like the execution engine that sort of orchestrates everything like we know. So I like to think of the runner like a stage manager. Think about like in a theater, right? You have actors and you have scenes and you have cues. Now the stage manager, which is our runner in this case, is responsible for coordinating activities between the different actors. You can think of the actors like our agents, and then we have cues which are emitted by those actors, and then the stage manager can take those cues and decide what to do with them by coordinating activities between the different actors. So in ADK, the runner kind of plays the same role as a stage manager. Now this is what a typical event loop looks like in ADK. It looks like a fairly complicated diagram, but I assure you that this user flow diagram is very straightforward. So basically what's happening here is the user sends a query. This is when you go into maybe ADK web interface or some interface, and you send a query. Your query gets intercepted by the runner. Now when the runner intercepts that query, what it does is it saves the user's message to session as the first item in session. And then when that's done, it runs the async method of the agent. So whichever agent is your root agent that needs to run, it's going to trigger the run async method of that agent. And when that happens, the agent begins to process or begins to perform the activities that it needs to do. Now, when the agent realizes that it needs a tool call, and this typically will happen if the agent invokes an LLM to perform some activity, and the LLM decides that it needs a function call and returns that request to the agent then yields an event, and that event is propagated upstream to the runner. And now what happens is the runner forwards that event upstream again to the user. So this might be to the user interface. So you know that there's a request from the LLM that a certain tool or function be called. And when that happens, the agent is paused at this point. So it's not doing anything. It's not consuming a lot of GPU resources because it is paused. And when the runner propagates that upstream, the runner now signals back to the agent that it can execute that tool. So we already have that tracking in state that a certain tool request has been made. And now when it signals to the agent can now run the tool because the tools are attached to the agent. So the agent can now execute the tool, and when it executes that tool, it yields an event again back to the runner, and then the runner, which is responsible for orchestrating the entire flow, commits that change to the session state again, and then forwards the event upstream again for display in the UI, and then signals back to the agent that it can actually resume processing. And now the agent, having now have the result of that tool call, can send that tool result to the LLM, which was the original request of the function call in the first place. So when it sends that request back to the LLM can now use that outcome or the result that it has to build in a final response for the user. And it sends that back to the agent again yields an event back to the runner, and then the runner now commits again to state that this is the final response, and we have everything we need for the user, and it delivers a final answer back to the user. So basically from all of this, the most important thing to keep in mind is that communication between the agent and the runner is happening via events, and the agent pauses between every interaction where it needs to emit an event to the runner and it needs the runner to perform certain activities for it. So this ensures that state is always consistent and the agent knows when to proceed when the runner has confirmed that state has been updated. So now we already saw that multiple services which the runner has access to be able to manage and maintain state. We know we have session service, we have memory service, and artifact service, which we've talked about in a previous video. So if you haven't watched that, please go back and refresh your memory on that. And then event types that are propagated or emitted, we have user inputs, which is the input the user sends, function call, function response, final text, and state delta. So state delta means there's a change in the state that needs to be committed. Now, session and invocation, we talk about that a lot, but the main difference is that an invocation is just a single user query against the system, and the entire flow of that query that results as a result of the runner performing the requested actions, while the session is the entire conversation, not just a single invocation. So in this sense, you can say a session can have multiple invocations. And then a session contains all events, the full state, while the invocation is just events for one query. And then you have the session ID, invocation also has an ID, and then lifetime of a session until it's deleted, while an invocation starts and ends just within the run async loop of that agent. So state and prefixes, we have prefixes which sort of determine how a certain state key value pair is stored. And when you have the app prefix, that means whatever you're storing in state at that point, you want it available across the application, while the user prefix as well is used for storing information that you want propagated across the user sessions. And then finally, you have the temp, which is only valid for invocations, so within that specific agent run. So ADK Web versus Programmatic Runner. Now, whenever we run ADK Web, which we have been using in previous videos, ADK Web automatically creates a runner for us, so we don't have to create a runner ourselves. And that's why you see so far we haven't been creating a runner in our code. And that's because we've been testing using ADK Web. If you're not using ADK Web or ADK Run, you have to create your runner yourself. And then that runner now orchestrates the entire flow of the agents. And that's what we're going to be doing next in our WealthPilot demo. We're going to be creating a runner, and that runner is going to orchestrate the entire flow of our stock analysis. So let's get into it. So now that we understand what the runner does, let's go ahead and build our first runner. Here in our WealthPilot directory, I'm going to go ahead and create a new file here. I'm going to call it runner demo, just a standard Python file. And I'm going to paste a bunch of code here and tell you what exactly it does. This is basically a Python file. We're using load.env to make sure we load our .env file, because when we use ADK Web, remember, ADK does a lot of heavy lifting for us. So whenever we use ADK Web, it loads our environment variables automatically and spins up the runner for us. But in this case, we have to do a lot of the things ourselves because we don't have ADK Web. Okay, so the first thing we're doing here is just specifying an app name, specifying a user ID, and then we're creating our main function, which will run. Okay, and then we're initializing the session service, memory service, and artifact services. Okay, now ADK Web by default will initialize in-memory for us and in-memory session service. But in our case, since we're building a custom runner, we need to configure the services that we need. And you don't have to configure all of them, just configure what you need. And here we're actually creating our runner. and we're specifying the root agent. So when you create a runner, you need to specify the root agent, the app name, the session service. And in our case, we're specifying the root agent, which we're importing from our agent.py file. So in our case, we're going to be running our root agent, which is our WealthPilot agent, which we built in previous video. Now that we have our root agent, we're setting the app name, session service, memory service, artifact service, and then we're creating a session for the user, and then printing a whole bunch of information out on the terminal. And if the user types quit or exit, we terminate. And if they don't, we assume that's a user prompt. And then it goes into this interactive loop that we have here. So we're printing the U inputs and the CLI, and then we're iterating through the user input. And then we're creating a content type for that user input. And then we're going to send that to our runner by using runner to run async. And that initializes our runner so it's able to process the user prompt. And then we're taking that content and then we're passing it to our runner using the run async. The runner can now kick off and begin to run all these processes, call the agents, the LLMs that it needs, and all of that. Here we're just printing out whatever text output we get from the events emitted by our runner. Finally, when all the process is done, we're just printing a summary. And the summary here, we're printing the number of events which the runner emits for us. So let's go ahead and run that and let's see how that works. I'm going to save that file. And then here in my terminal, I'm going to use uv run project. And this time around, I'm just going to run into a Python WealthPilot.runADemo, which is the name of our file. Okay. So if I hit start, that should go ahead and trigger our runner if it's watching. Okay, there you go. So our runner just started and we can see all the information which we are printing out showing here in the terminal. And here, I'm just going to give some queries to the runner and let's see how it does, just to test that the runner is actually working. Okay, so I'm going to say I have 50K to invest, moderate risk, 20 years, and analyze AAPL. So let's say I want to analyze the AAPL stock for 50K investment over 20 years and moderate risk. So we can see it's invoking our root agent and it shows that process in there. Okay, there you go. We can see it's calling functions. Our planning is running. Okay, here's the plan. So we know our planner is working. And essentially we can see our ticker is validated and our stock analysis is running. Okay, so that's going as expected. And finally, we should have our projected portfolio as well. So moderate risk and mitigation strategies, your comprehensive portfolio has been generated. So everything's working the way we expect. And we can see as well our in-memory service is working to save the session details to memory. Okay, awesome. Now we're just going to hit exit. And if that works, we should see a summary as well. Okay, you can see we have about 14 events emitted by the runner. This confirms that our runner is actually orchestrating the entire process like we expect, and is triggering, calling the agent, calling the LLM, and coordinating events, update and synchronization to the UI, upstream, and back to the agents, and all of that. So we know our runner is actually working. All right, so that's it for this video. I hope you've learned something. I'll see you guys in the next one. Bye for now. So now that we have our multi-agent system built out, we want to start looking at how we can deploy our multi-agent application locally in this video. So basically, we're going to be looking at the multiple options available for us in terms of deploying or running our multi-agent system locally, or maybe in some on-premise environment. ADK actually supports multiple ways to run your multi-agent system locally, so you're not limited to using ADK Web or ADK Run. So while we've tested ADK Web, which we've used previously, it gives us a dev UI out of the box and an API server. Ideally, you want to use this for prototype or debugging. And you have ADK Run, which basically gives you a terminal read event print loop. So you can interact with your multi-agent system from the terminal, also useful for quick testing. And then you have the ADK API server, and this is where it gets interesting. This is a headless REST API that allows you to interact with your multi-agent system using CLI commands, Postman, or whichever client that allows you to connect to an API endpoint. You can basically use that to interact with your multi-agent system. Now this becomes interesting because now it helps us realize that we can build custom UIs in front of our multi-agent systems and then connect to them using the API endpoints. And then finally, if you want to build your own custom runner, you probably want to set up a custom main.py file That gives you greater control, and you can run whichever workflows that you want to run in that backend API 7 endpoint in production. Basically, how it works, like we've seen, ADK web prototyping, ADK API server, testing, validation, and custom runner, use custom min.py file. And then finally, if you have all the testing completed, you probably want to Dockerize the agent or your multi-agent system, so it's easier for you to deploy wherever you want to deploy, either on Google Cloud Run, on some third-party vendor or cloud provider. So let's quickly look at what ADK API server actually gives us. In our WealthPilot application, which we're using for this test, I'm just going to run ADK API server. It's actually CLI command available for you from ADK directly. So if you just run ADK API server, that should spin up a REST API for us with an endpoint which we can access to test the application. So let's go to the browser and let's go to localhost port 8000/docs. Now it should generate a documentation for us. So we get a Swagger API documentation out of the box that tells us all the available endpoints that ADK automatically creates for us that we can use to interact with our artifacts, our sessions. We can create sessions for users, list user sessions, delete user sessions as well. There's just so much we can do, and we can give it a test. Like if I go to the list apps endpoint, and one good thing about Swagger is you can actually just test it from the doc. So I'm going to click execute. This should hit that endpoint and we should get a response. So we can see our request URL, list apps, and we got a response for the different multi-agent applications that we have. Remember, we built the ADK kitchen and the WealthPilot. And here in the CLI, we can see those endpoints were hit and it returned 200. So this is a nice way for you to begin to test the endpoints or your application and seeing how it actually works and how you can build a custom UI around your multi-agent system that you've developed. And now that we have that running, we can as well hit a custom endpoint to create sessions by just running curl to that custom endpoint. That'll help us create new sessions for users as well. So this sort of begins to open the possibilities of what you can build to interact with your multi-agent system. ADK also provides the run and the run SSE endpoints. Now the run endpoint is mainly for batch transactions. So basically if you use the run endpoint and you send a query, let's say user message in this case, it's only going to return once that transaction is completed or once that RESTful request is completed. When you use the run SSE, it's going to stream the response. So every event that's published, the server is going to return that event for you. So you will have partial responses and you can stream that on the UI, making for a much better user experience. Now, if you're ready to move to production, ADK actually provides you with a guest fast API utility. And what this basically does is it sets up for you a production ready UVCon fast API endpoint that you can use to run your multi-agent system. How you access this is from the Google ADK CLI SDK and just import the Get Fast API app. And it allows you to configure your agents directory. And ideally, you're going to set this to the root of your multi-agent system. Origins, web. This is if you want just API only, which ideally you want to use just API only if you're deploying your application to production. You don't want to deploy ADK web as well. And then you have the session service URL also available, so you can customize what database manages your sessions directly. Now, what we're going to be doing next is we're going to be building a custom Next.js frontend for our multi-agent system. And to do that, we're going to have to build that front end, and then we're going to use the run SSE endpoint to be able to connect to the backend API of our agent. And when that happens, when we connect to that backend API, basically, since we're going to be using the Get Fast API app utility, it's going to create that fast API UVCon application for us, which then houses our runner. And then when we connect to the runner has access to all the external services, agents, and tools that it needs to run to fulfill a user's request. And also, we're going to be containerizing our WealthPilot application using Docker Compose, so we can easily run our front end and our back end by simply just running Docker Compose up. So that way it helps us prototype much faster as we build and add new features to the application. We can have hot reload in there as well, so it automatically hot reloads changes whenever we make changes to our code. So now that we're ready, let's get into it and start building our front end and also integrating that with Docker. So let's get to it. All right, so now back in our WealthPilot application, we want to start to make the setup to be able to run this in a Docker container. So the first thing we want to do is to set up our main.py file, because in this case, we want to use the get fast API util from ADK to make sure we set up our production API server. Okay, so in here, I've created a new file within the WealthPilot directory, and it's called main.py. And here I'm importing the fast API app utility from Google ADK CLI. Okay, and then setting the agent directory. Now, something you need to understand is that the GetFast API app utility expects the agent directory to be the root of your agent systems, and is useful because you may have multiple agents that you want to run, like we've seen previously. So I just have some logic in here to manage that. We're setting allowed origins, and then finally here we're initializing the GetFast API app, which should create our production endpoints, and we're setting web to false here because we do not want to deploy ADK web. And then the only other thing here as well is we're creating a custom downloads endpoint, and this is because we want users to be able to download the PDF portfolio report that's generated for them from their browser directly. So that's all this code here is doing. And then finally, we're just initializing on port 8080. And with this, we should be able to run our application. Now, something else I've done is gone ahead and added a requirements.txt file, because I'm going to be using pip in the Docker file. So I have the Docker file here, and you can see in our Docker file, we're using the pip install requirements.txt file to install dependencies. However, we're not copying over the application code since this is in dev. We're just going to use a volume mount, so that way it hot reloads by default whenever we make a change in directories we want our containers to hot reload. And that way we can have this really fast iterative development. And we're exposing port 80 here, and we're starting with a Python 3.13 Slim Docker image. So with that all in place, we should be able to build our Docker image. And then for the UI, I've gone ahead and created a basic Next.js application. So it's just a standard Next.js application. The key things you need to understand about this app is it has a Docker file. So again, here we're just packaging and building the Next.js application and exposing port 3000. Okay, the other thing we're doing in here as well is in the app, we have a page.tsx file. And this is the only important file. It's just a simple Next.js application. And here you will notice that we're defining the backend endpoints. So this is where we want our Docker container to run. So this is where our backend Docker container is going to be running. So we're accessing it from that endpoint. We're setting the app name, the user ID. We're just setting this to demo user now. And then we're creating a new session for the user on mount. So when a new user loads the application, a new session is going to be created for them so they can start interaction. And you can see we're using the endpoints which ADK provide for us. And here we're handling download using a custom handle download function, which will just open the endpoints which we created on our backend in our main.py file here. And that's basically the chunk of it. The only other thing here is just functions to handle UI interactions and all of that. Okay, so now that we have that, we can go ahead and spin it up. Okay, one more thing is I've created a Docker Compose file. So we have a Docker Compose file here at the root of our multi-agent systems directory. And what this Docker Compose file does is provide us the ability to start our front end and back end with a single Docker Compose command. And you can see we are setting the context in both cases to both the front end and the back end. And we're setting the paths, we're loading our .env file for the back end here, and we're setting our volume mounts as well in here. So one nice thing about Docker Compose is it helps you be able to organize your applications as much as you want to and ease out the stress of having to go run or start those applications from their individual directories. With that all set up, from the root of my application now, which is our multi-agent systems, I should be able to run Docker Compose up build, which should kick this process off by building the Docker images for our backend. So we can see that running, and it has built the one for our frontend as well. And we can see that our frontend is exposed on port 3000. And if that's working, we should be able to visit our browser and go to localhost port 3000. And there you have it. That's our custom ADK frontend. And we can see everything is running here on the back end. And we can see that a new session was just created for us. So it's working. And now let's go ahead and interact with the application and see if all the various subcomponents are actually working as expected. So I'm going to say analyze APL stock for me for a 5 years investment of, let's say 50K, moderate risk tolerance. Now let's see what's happening. Our runner is thinking. We can see our loading states, so it's processing as well, and we can see run SSC endpoint is called, and there you have it. So everything's working. We can see the state here as the different agents have been called. Portfolio advisor is running right now. Stock analyst was called and it returned some analysis. Portfolio advisor should be able to do the portfolio analysis, and if everything works, we should have a PDF report. So there you go. We have a PDF report for our portfolio, and we can see the full analysis here. Some formatting needs to be done here to the text, but besides that, everything else works. We can see APL. Awesome. So we can go ahead and download the PDF report, and we can see our 5-year investment portfolio analysis. So there you have it. We now have our multi-agent system running in Docker Compose locally. Obviously, we're running with in-memory session service. So if you go ahead and stop Docker Compose here, you're going to lose whichever artifacts or conversations that have happened. So in an upcoming video, we're going to start looking at how we can productionalize this application and deploy to maybe Cloud Run or Google Agent Engine, and also maybe make use of Vertex AI memory service and start using those cloud resources to ensure that we have continuity whenever our application restarts. So that's it for this video. I hope you found it useful. I'm going to have all the code in the repository so you can go ahead and look through. And if you have any questions, feel free to leave a comment. I'll see you guys in the next one. Bye for now. Ciao.